Hey, back again with another show for you guys. Friday evening as well. Can't be bad. Hope you guys are all doing okay. For me it's 10 p.m. And yeah, the pubs are closed now, so even if I wanted to go for a pint, yeah, that's just not on the table. COVID gets you after 10 o'clock apparently, if you believe all that. So anyway, let me introduce some of the people that we already have in the chat. We have Helen Degenerate, nice to see you in. Beeble for Life, Flat Earth Database, wow. Diane Shuker, Alexander Lightwater, and Flat Earth Data, good day to you as mate. The Snark, we have Pridoxine Oxide. It's a different name, never heard that one before. Matrix Media, John Bernards, who's actually on the panel, nice to see you in. We have Ian Adams, we have Page 42, TMF, and Steve Hamilton. So, how are you all doing tonight? Let me also introduce the guests, the panelists that we have already. We've got Crow, we've got John Bernards, we've got Ruhif, and we've got Brandon Toy. How is everybody doing tonight?
Lovely.
Doing good.
Hey.
Do you know, it's weird, I say tonight and I instantly thought, oh my goodness, Ruhif is in the future. Because he's just told me it's more.
It's the 26th of September.
I'm talking to a time traveller. Oh.
Everything there is wrong.
Ranty.
The future upside down and etc.
Yeah, the future is definitely upside down, that's right. If you believe in the globe anyway. Yes, go ahead, John.
Sorry, I have to say it, but time is just a concept, so take it easy.
Okay. Crow, you had something to add?
No, nothing much. I uploaded one of your videos and I didn't get any automatic strike or something. But I've got a comment saying that you might be, that's you, Ranty. You might need to be above 10,000 subscriber in order for me to get a copy strike for uploading your stuff. Not sure.
I don't know. I don't think it. To be honest, I think I'm going to stick by what I said yesterday and just say that, you know, if I wanted to be an arse about it, I could go over to your channel and strike you, no problem, and then they wouldn't, you know, because my channel already had that original content up. They would do something about it, but it all comes down to the person, you know, what type of channel you are and whether you're protective over your own work, you know. In which case, I'm not, so I don't strike anybody for that. So you're never going to get a copyright strike from me, but other people, even with 1,000 subscribers, could copyright strike you if you use their work without them giving you permission to. So I don't think it really matters.
But there's fair use protections, right? So if someone's criticising your work, that's fair use.
Well, that's what Crow was trying to say yesterday, because...
Yeah, you would get in trouble if you struck him, if you did that.
Well, no, I meant Crow was trying to say that there were channels out there critiquing, I think it was Daz the Cameraman, and he's lost his monetization or something.
Okay.
So I believe.
Okay, but I would say I would pay for everybody that will take something from me, so it's right on. Just take it, spread it, and I will pay for it.
Well, it's better to be safe. Like if you need to discuss something or criticize something, like bring some screenshots. You don't have to play the video.
Yeah.
Yeah, but what fun is that? Why should we all be walking on eggshells? I mean, the fair use policies are in place to protect us during these times so that we can share and comment on each other's stuff. In my opinion, anybody that strikes you for the kind of stuff we do in this community, unless it's something egregious where you're attacking their family or something way out of line, is a baby.
Yeah.
Put it nicely.
Everything in FE shall be without cost.
It's a pussy. You have the right to say pussy, Brandon Toy.
I didn't think of it. The word pussy didn't pop in my head. don't know. Otherwise, I would.
Do you know?
Really? Because I was just thinking about Cox Zucker report.
Oh my goodness!
Randy,
Of course.
Randy was in bits last time.
As soon as you land, Pete, the tone of the conversation just goes.
Well, he said baby. He said baby. Come on, it's stronger than that, right? It's
You
stronger
like
than that.
it. You like it. You like it.
Snowflake.
But honest to God, how you doing, everybody? But Ranty, last time we spoke, right, I was just thinking about this. You were in bits. I was going to ask how
I'm well,
your
thanks,
hernia
Pete.
was, right? You were in bits with the Cox Zucker super chat. So, but I mean, pussy isn't too bad, right? But that's more direct as well.
Cocksucker. Yeah, okay.
Dear
But
me.
they're two prominent scientists, right? Cox and Zucker. I'm just saying.
It's too
Just
much.
words. What's wrong with you?
Don't start it again.
I'm sorry. I
It's
apologize,
over.
John.
It's over. It's over.
John Bernard. How you doing,
It's
my friend in
over.
Iceland? I'm sorry about that. I go on mute a few minutes. I just say welcome to everyone. Or not welcome. How you doing?
I love
Welcome.
you. No problem.
Excellent.
Excellent.
Hey. So anyway, the stream's called "It's the End of the Line, Guys," and yeah, it will be for the show. I've been offered a job, so I've got my first day's training next Friday. So I've got to phone them up on Monday to accept, which I'm going to do. And John, stop making the noise, bloody hell! And
Sorry.
yeah, so I've got a week more of the show, and then that's it. It's done. No more show, unfortunately.
You'll still do shows, Ranty.
Nah, I don't.
Yeah,
No.
It's 10 p.m. there, right?
I don't.
Yeah, I can't. It's not gonna work with the job, unfortunately.
You tell
what
me
are you
on the
doing?
weekend you're not going to be like, hey, I feel like popping on and having a show. I got these thousands of people here. I can get 100 people on at any time. I feel like hanging out.
I don't know. I don't think so, to be honest. No.
Wow.
Yeah. No. I've given 5 years to this for the cause, and I feel like I just need a clean break now.
Take a break anyway.
Well,
Clean break.
anyway, listen, hang on. Talk about that a bit later on in more detail. Let's have a more jovial sort of Friday beginning.
Oh, it is jovial. It's jovial. I've got another week left of
Well-
this, so I'm not too bad. I'm happy enough, I suppose. So yeah.
Can you say what your job is? What it's doing?
I'm not going to do that because the last thing I'm going to do is put that information out for the trolls to try and find me. No, that's just not going to happen.
Cool.
You got a job for National Geographic, didn't you?
Or NASA?
Well,
What's the
congratulations on your
European
job,
Space
though.
Agency?
ESA.
Is the UK in ESA?
Congratulations, though, Ranty.
Sorry?
Yeah, nice one.
Say that again.
Is the UK
Congratulations.
part
Oh,
of
right.
ESA?
Cheers. Cheers. Thanks.
Yep.
Right, let's get
All right,
back on
who's up
track.
for fight?
Yeah, who's up for a fight? Come on, we've got Ruhif in here. He's desperate to get beaten up tonight. Come on.
But Randy, let me just say though, that's why I say though, but let's hold on to it for later on. Now everything is just coming to a climax, if you want.
Oh, shut the fuck
That's
up.
what it's all been about. You know. But hang on, this is what it's all been about. 2020, flat Earth, where some of us are in this for 5 years. Now your voice is stronger than ever in potential. That's what I would say. Potential. That's what I'm saying. So leave it till later on, and welcome everybody to the last week of Ranty's Flat Earth. I even brought my guitar and harmonica.
You're gonna have to make a song up, Pete. You're gonna have to make a song up. You'll have to start doing your shows.
I swear to you, man, I could make a million songs up about all of this. I just always sort of tried to see a future and work it out. But that's what I'm saying now. Everything is culminating. So, well, yeah, definitely. If I put my mind, I remember before I talked to you about doing a video together, like you doing the graphics and me just giving the input. Man, that I could do 101 of those videos. It's just focusing on one particular area. But again, what's it all about? I've come to realize the truth is already known. So whatever's unfolding is according to a greater plan. And in our own way here, we're all playing.
Do you know you say that every show, Pete? Can you learn something else to say?
Well, I'm just saying, in our own way, I've spoken about it. I've spoken openly.
You've said the
about
same
everything
thing
I've
every
said.
time you come on. The truth is always known. It's like I hear that 10 times every show. Come on, Pete. Think of
Do you
something else
not
to
think
say.
it's always known? Do you
No,
not think this is
no, I
all
don't,
scripted
Pete.
out?
No, not at all.
Really?
Yeah, really,
You're a great
Pete.
understanding.
I don't think
Well,
anybody
okay.
agrees
Well,
with
hang
it.
on, Ranty.
You're the only
Hang on,
one that
please.
waffles it. Brandon,
Well,
do you
hang on,
agree? Brandon, do you agree?
Well, hang on. Let me just, before you go to Brandon.
See, hang on.
Okay, let me just say this then.
I want
Sorry,
to say
John.
something with you, my master.
Let me just say this.
No, I wanna-
How long do you think it's known that the Earth is flat?
Right, okay, so, Brandon, I was asking you a question then. Pete's not taking over this show.
Yeah.
Yeah, he's not gonna dominate this show like he does every other one. No, so go on. How many times when you hear Pete say that the truth is already known, do you think that the truth is already known?
Man, if the truth is already known, how do we know that we know the truth? He says that quite a bit. I don't know what that honestly means. Do some people know the truth? Maybe. I have no idea.
But I reckon if you took every time that he said that sentence, but it's everything else that he builds around it into sort of like a 2-minute. It takes about 2 minutes to go around that whole section that he says. But he says that about 6 or 7 times every show, which means that if I'm doing a 3-hour show, we get 15 minutes of Pete saying the same thing about the truth is already known.
Now that is a true statement, and that is something that I will agree with 100% because I have almost memorized word for word what he says. As anyone who listens to this show on a regular basis, I'm sure.
Balanced Truth says that people don't do ranty like that. Get the likes up. Show love people. What's that? Have I got dislikes on the show or something? I have no idea. Probably. The trolls have probably already been in.
14 dislikes to 11 likes already.
Ooh.
I don't think that is. I don't think that's Glover's, to be honest.
Do you know? Well, it was 9 dislikes before the show even started, I think.
Yeah.
Now, why would you say that, Ruhif? How the heck would you possibly know that if that's Glover's or not?
No, I'm just giving my opinion. I just don't think it's Glover's. It just feels like it's some people that don't like ranty that are flat earthers.
Okay, that group of people. So you think that they have notifications on for Ranty show and pop on here every time?
Probably.
Give them a dislike?
Flub it down.
It's either that
That's
or
possible.
Glover's too, right?
Yeah, one of the two. But I think it's
you're
pretty
right.
lame for a bunch of people to come and listen to a show or pop in and hit the dislike just to spite someone because they don't like what they're talking about.
I agree.
You said dick-like, Brad.
Oh, Jesus Christ.
You did. I didn't say it.
I did say it.
Pete, I think you need to find yourself a woman, mate. Really quickly would be a
There's
treat.
cracking call
Maybe
in
in
the
this last
chat.
week.
Anyway, Rohit, we were talking about something.
Yeah, one sec. There's
One
a cracking call in the chat.
Yeah.
Repeat Jay.
Yeah, repeat, Shay.
Yeah.
So everyone condemns me. Let me say this. You put me on mute there. You don't have to
Hold
put me
on, what's
mute.
that? Shout out to Bob. Yeah, I do, Pete, because you didn't listen. You were just talking over John when I was saying, no, I'll ask Brandon something, and you completely ignored me and carried on shouting at John and wanted to carry on the truth is already known,
I wasn't. I was asking
section
you a
of your
question, man.
waffle that you start with.
That's no way to talk to me, and I was asking you a question.
It's the truth, though, Pete. What do you want me to say?
No, it wasn't. What I meant by the truth is already known. The flat Earth.
So here we go. He's getting into it. He just brought it back again. Anyway, right. Let's not truth. Let's not truth is already known. Right. Shout out to Bill G and Dawn Hub in the chats. Nice to see you in. Right. Go on. I want to hear. Right. John's got a question for Ruhif. Go on. Go ahead.
Do you remember we were talking about before the show?
Yeah.
Okay, start it.
Huh?
Sorry, that was me closing windows. Sorry.
Tell me about it. What you are saying.
Yeah, you say that Google Earth is a flat map, and
Yeah.
I've posted an image. I've posted an image in the general chat showing that it's not.
But I have done it by myself. Every map has to be granted by flat horizontal plane. Every map is flat, and the Google Earth is built on flat Earth.
No. Can you show my image, please, Ranty? Yeah. That is a line from the east coast of Australia to the west coast of Australia. And when you plot a line on Google Earth, if you go to the altitude tab,
Wrong
on
graphic.
Say again?
Wrong graphic. You have to zoom in to get the real graphic to understand that this is flat Earth. This is graphic for globe. I just have to say it, then he can. Now you can.
Yeah, so there's a drop-down box there. Yeah, there's a drop-down box there where you can choose either the line clamps to the ground, in which case you'll get a curved line if it clamps to the ground, or you can set this absolute, which sets it a certain height above the ground. Yes. A curve. What's the length? Like 3,000 miles across Australia? Is that what you're talking about? I don't know. Hang on. Did I close Google Earth? No, I didn't. All right.
I think
so measurements. I've got 2,564 miles for that one. Yeah, it doesn't change actually if I
A mad distance, isn't it?
Oh, they could just be doing the straight Haversine formula.
Ooh, that's a fancy word.
What is that?
What's that? What's that, Ruben?
Tell us about this formula. I am very interested.
The straightforward handstand formula.
Yeah, well, then, if it's clamped to the ground, they may. Yeah, there you go. Yeah, that distance might just be the Haversine formula. It probably is.
There we go again. As he slipped his finger up my arse.
Did you jizz everywhere, Pete?
Pray tell, what is that formula?
That's how to do distances on a sphere.
What do you mean?
I can't recite it.
Oh, okay.
So you're assuming square before you take in.
It's a geodetic formula based on spherical mathematics.
You're assuming a square.
Okay.
Yeah, this is just a mathematical model he's showing us, John. That's
well,
all
then
it
again,
is.
Nautical model.
It's fallacy.
We talked about the Sydney to Santiago flight, right? What is that distance on a flat Earth? Well, first of all, show us your map of Sydney to Santiago. I care because it's a great.
Tell us when you measure the distance, Ruhil.
But hang on, that formula is a conversion, right, Ruhil?
What do you mean a conversion? It's a formula to decide.
You said when you take the what do you call it, the Haversine formula?
Haversine, yep.
Haversine formula into consideration as a conversion aspect to calculations. And now you're saying that there's a different definition between distance on a sphere as opposed to what measured in reality and then converted to a sphere via the Haversine formula?
The Haversine formula is incredibly accurate. There are two formulas to work out distances on a sphere, or an ellipsoid, actually. The Haversine formula is purely spherical. There's a Vincenti formula, which is a tiny bit more accurate, but the Haversine formula is, close enough to
what are you actually converting? The measurement to a spherical?
What do you mean converting?
What's the form? A formula always converts something. There's always something on either side of the equal sign, Ruhil.
Yeah, latitude and longitude from point A to point B.
Okay. And they're converting a flat distance, a straightforward distance.
They're converting it's a distance on a sphere.
But they're measuring it
don't
in
understand what you
reality,
mean by
right?
converting.
But they're measuring it in reality. Measuring Australia, there's a railway that goes all the way across Australia as well, right? Ruin.
Yep.
Right. So they're measuring from one end of the railway line to another, which is perfectly flat for the very most part. We'd agree. It appears to be flat. So when you're converting it using the Havenstack, the Havenstack formula, you're converting this direct measurement to a sphere. Is that correct?
I'm taking 2 latitude and longitude points, putting
From a
them into
sphere.
a formula and getting the distance.
Can I come in between and you can keep on then? Sorry, PC.
Sure.
I just have to say just between you're talking about. So you are taking a formula that is a globe formula to use as assumption for your globe. Do you know what it is? Do you know what you are doing? It's fallacy.
No.
You're right, John.
You guys need some fundamental education in philosophy.
No.
Ruhif,
And
Ruhif,
science,
John is
philosophy of
right.
science.
Can I interject here?
Let me just say, Flutter,
I
John
know
is
what
perfectly
you're
right.
doing, so stop it.
Hang on, please. And Flutter, I'll be very brief. John is perfectly right, Ruhif, because immediately you introduce longitude and latitude, which only apply to a sphere, right? A sphere,
No,
or
you can have latitude and longitude on an AE map.
Cartesian coordinate system applies to a flat Earth. Thank you.
I can use latitude and longitude on a flat map. On the AE map, I can apply it to that. That's no problem.
No, you can't. How can you?
Yes, I can.
Tell me how you can.
I'll show you my formulas to do it. Would you like to see them?
No, but just give us a verbal and let us visualize how you would do it on a flat plane,
Well,
on a
latitude.
table. On a
Latitude
table,
is
a whole table. You're actually, hang on. I set the example for you because you said you can do it. On my table, right, which is a square table, how are you going to set longitude and latitude coordinate system to fit every possible point?
On a circular table with the North Pole at the middle, you call the North Pole 90 degrees north and the equator 0 degrees and the outer edge as 90 degrees south. And the longitude is basically just the spokes of the wheel. It's an easy
You're bringing
mathematical
in the fallacy here immediately, man.
Can I come in between again?
On my square flat table, apply the coordinate system.
We're not talking about a square table. We're talking about a round table.
Sorry, I have to come between again. You don't know if the longitude lines you are talking about is the reality. It's the reality from your globe model, but you don't know if it's a reality.
But John Bernard, he's wrong
The
anyway.
question was...
Hang on.
So you are wrong
anyway.
It's fallacy again.
John Bernard, he's wrong anyway. If you think about a circle on a flat plane and you're looking down on a plan view in it, tell me how you're going to grid it out in a latitude longitude system as opposed to a grid like coordinate system, a two-dimensional plane.
There is no proof.
Are you telling me, Pete? You can't take a latitude. You're telling that you can't take a latitude and longitude and locate it on an AE map. Are you saying that you can't do that?
So we're all looking down at a circle. Paint the picture for me.
Yeah, I just did. North Pole is 90 degrees north.
Are located within that circle.
Don't fit the reality.
What are you going to do? What is the longitude?
Can I interject now? Can I interject? You're talking about coordinate systems, talking about longitude and latitude. Ruhif, can you do it on an ellipsoid?
Vincenti, I think, does it on ellipsoid, and I personally can't do it.
Yeah. So listen, why are you using spherical geometry for the longitude latitude? There's a reason for it. Do you know
reality.
Why?
It matches reality.
There is not one formula that you can have that represents the perimeter of an ellipsoid. You have to use spherical Euclidean 2 pi r and everything you do, which is transferable on a flat disk. Okay? It's all transferable, 100%.
I am a sailor. We use straight lines. We not use the globe spherical lines.
But something a part of the Earth is contoured, right? So we're talking in reality to here. The Earth is flat, but the sky is contoured. So a grid-like Cartesian coordinate system for the flat Earth centered at the north center, and then the spherical coordinate system for the sky. And funny enough, Ruhif, we'll agree on this, that the longitudinal coordinate system for a spherical ball Earth, it coincides with celestial coordinates, declination from a specific longitudinal standard. Isn't that funny? Isn't that funny? So your spherical polar longitudinal coordinates coincide with coordinates for the infinite sky. Isn't that funny? I'm telling you, it's all metaphor, and you know it as well
May
better
I,
than anyone.
may I interject, Pete? Ruhif, I asked you this a while back. I asked you, can you calculate the distance to the horizon using the Rayleigh criterion? And you said no, correct?
Using the Rayleigh. What?
Yeah, the Rayleigh criterion. You know what?
Yeah,
Can
correct.
you tell me what
that's
the
gibberish.
Rayleigh criterion? Can you tell me what it is?
Oh, what is it? I know the factors
It's
in it.
gibberish,
That's the,
but you don't. It's
No,
gibberish,
it's
but you don't know what
gibberish.
it
It's
is.
gibberish to say that you can measure the distance to the horizon using the Rayleigh criterion.
I
That
know
is
you
absolute-
can. I'll give you the math right now to show you the
Oh, no,
calculable. So
I've
the
got the
Rayleigh
math.
criterion, I'll tell you what it is. 1.22 times the nanometer of 500 divided by the size of the aperture slit. Okay. In this case, we're talking about the human eye, which is 0.005 meters. And we're going to talk about 500 nanometers, but we're going to turn it into meters for the calculation. So we're going to take 1.22 times it by 0.000005 divided by 0.005 will give you radians of 0.000122. We times this by 57.3 to get the degrees, which works out to be 0.0069. That degrees is based on the angle of visible light's maximum resolvability. In other words, that 0.0069 is the maximum angle of resolution detail on 500 nanometers. Okay, that's what the Rayleigh criterion is all about, the 1.22. How do we calculate? Now, this is really fun.
You said 0069, by the way.
It's 0.0069.
Okay, sorry.
Now,
okay.
if we take,
okay.
listen, if we take the distance to the observer, or sorry, the distance to the horizon for a 6-foot observer, we get about 15,842 feet. Okay, we're going to divide it by the tangent of that degree of angular resolvable detail, which is 0.0069. You're going to get 131 million miles, 477 feet, maybe 200 or 400. Sorry, 131,500,200 feet, roughly. I don't have a calculator in front of me.
To cut you off, no one's listening to the numbers.
Let me finish.
Get to your point.
Let me finish.
Get to your
Yeah,
point
you better
without all
listen
these
to the numbers,
right?
because you better listen to the numbers, because I'm using the Rayleigh criterion 1.22 to calculate the circumference of the Earth ball. In other words, what I'm saying to you is that if we take the 1.22, we do the calculations for the nanometers and the size of the aperture, we end up with a degree of 0.0069. Now, let's take the size of the Earth in feet, and let's take the distance to the horizon, because we know those two facets. So we do arctangent, 15,840 feet, divided by 131,477,280 feet. That's a rough number. You're going to end up with 0.0069. So we have the Rayleigh criterion offering me the angle of resolvable detail based on the wavelength of light, which works out to be the same degree using those two measurements. Now, what's really awesome about it is that if we take the that 0.0069 and we divide it by the tangent of the distance to the horizon, we end up with the size of the Earth. This is based on visible wavelength of light. This is why I think the hijacking of our vision has been taking place.
I think you mistook. You said 0.0069 as opposed to 0.000069.
Yeah, I didn't pick that up, Pete. I fucking tuned out.
Listen, it's always going to be 0.0069, always. Okay, for both calculations. What I'm trying to tell you here and convey to you, Ruhif, is that I can calculate the size, circumference of the Earth with the Rayleigh criterion. I can calculate the distance to the horizon with the Rayleigh criterion, as I just did in real time with real math.
So what is the size of the Earth?
Finished?
Flat Earth data, the real Earth.
I'm not saying what the size of the Earth is. I'm saying through the Rayleigh criterion, which is based on the visible wavelength of light. They've hijacked it and turned it into an Earth ball. And I just showed you the numbers. I just showed you the numbers.
Hang on, you don't agree with the Rayleigh criteria, so therefore it should reflect reality.
I don't understand it. I don't believe.
So the Rayleigh criterion is based on the visible wavelength of light. For the human eye, it's about 450 to 500 nanometers.
For the
human eye, that's correct.
right?
Right. So
Now,
how big
so
is the
listen,
real
you
Earth
finished.
matter data?
So
Have you
listen,
finished?
I'm just giving you the Rayleigh criterion formulation, proving to you it's hijacked, and you can derive the horizon and the size of the Earth from your eyeball.
Right.
Okay?
So how
That's
big
it.
is the Earth
From
flat
your
Earth
eyeball
data?
is the key, right? From your
I'm not
eyeball.
saying what the size is. I'm saying they've hijacked our vision and given us a size from our vision.
Okay. Have you finished?
Go ahead.
Excellent. Okay.
Go ahead,
So you
Roy.
keep saying from your eyeball and getting a number. If I get a camera which has a much larger aperture, the whole
Again, it's still
result
subjected
of the
to the
formula,
It's still subjected to the 1.22 diffraction limit because all
Yeah,
the
but the
sensors in
result-
cameras,
No,
all
stop.
the sensors in the
Stop.
cameras
I've gotten
are all
5
the
words
sensors
out.
in the
Stop.
cameras.
I've gotten
Listen,
5 words
all
out.
the
I've gotten
sensors.
5 words out.
Yeah, but
I've
I'll
said 5
educate you on the
words and you've
cameras.
interrupted. I'm going to
Relax.
Okay, let's
Please stop,
hold
okay?
on, hold on,
I'm gonna
Roy,
keep talking.
hold on. Let's let Ruth answer, please.
Right. So your whole thing was based around the human eye. I said as soon as you get a camera with a much larger aperture, the result of the formula changes. The angle that you get at
So
the end
again,
changes.
Ruhif,
No,
you're wrong.
stop.
It's called
Stop.
the delimited diffraction
Stop.
system.
Stop.
1.22
Stop. I'm going to keep
is in
talking.
every
I'm going to keep
Yeah,
talking.
come
I'm
on.
going to keep
But you're
talking.
full of shit.
Right,
You're
just
full of
let
shit.
him.
I
Just let
debunk
him.
you.
Hold
talking.
on. Just let him finish his point, and let him get it all out. And then when he's got it all out, then you can respond and debunk him. You know, but let him at least hang himself first. FED.
Exactly.
Right. So the angle that you get if you plug in a larger aperture, such as if you had a camera, gives you a different angle at the end. But in reality, the angle to the horizon does not change whether you look at it through your eye or a camera. I'm done.
Yeah. So every camera is a limited diffraction system. Ruhif, do you know what a limited diffraction system is?
The diffraction limit applies to cameras with circular apertures. Sure.
That's right. Anything with a circular aperture, including the human eye. Do you know what camera sensors are basically capturing with their sensor? What wavelength of light do they calibrate for?
Between what 400 and I don't know 750 thereabouts.
So both functions of the human eye are the 1.22 angular constant and the 450 to 500 nanometers of light. So that's where the 1.22 comes from, is the actual calculation of that visible nanometer of light through an aperture. That's where the calculation from. It has nothing to do with your camera now.
Average. That's an average
It has
wavelength.
everything. Listen, but it has everything to do with angles and light. That's it. Okay. So whether you like to admit it or not, I just proved using the Rayleigh criterion, you can calculate the approximate distance to the horizon. Nothing
And then
to
as soon
do
as you
with
get a camera, it
nothing
fails.
to do. We're not talking about the camera, bro. We're talking about the human
I
eye.
know you don't want to talk about the camera.
You want to talk about the camera. You want to talk about the camera. I want to talk about the human body, the human eye, and the calculation using the Rayleigh criterion. You want to use a camera because why do you want to use a camera, Ruhif?
Because it makes your argument ridiculous. That's why I want to use it.
How does it do it?
Because it changes the result of the formula. You're trying to imply
it changes the result of the formula, but does it?
Yeah.
What does it do with? How does it change the angle relation to light?
It makes the Rayleigh criterion bigger. If you've got a bigger aperture, you've got less.
So a different lens size and a different aperture size. What happens, Ruhif, to light?
Yeah, it changes the size of the result of the Rayleigh criterion.
Right. So nothing to do with Earth curve, right, bro? Everything to do with angles of
I
light through
agree.
aperture, right?
I agree that the Rayleigh criterion has nothing to do with Earth curve. That is correct.
That's right. So how can
Yes,
I calculate?
correct, thank you.
How can I calculate the distance to the horizon using the Rayleigh criterion then?
You can't. That's my fucking point, you idiot.
I just did it in real time with using math right over while you're in present moment with me. I just did it. You want me to do it again for you? You want me to give you the math for you?
I can tune out for another couple of minutes if you like. Yeah, go ahead.
So you don't want to acknowledge that I just provided you the math using the Rayleigh criterion to calculate the distance to the horizon. You want to deny that in a public forum?
Like I've said, your whole.
So you want to deny it in a public forum that I just provided you the math using the Rayleigh criterion to prove the distance to the horizon. Anybody can go back and listen to what I just said and apply the Rayleigh criterion.
They are talking about. The public don't know what they are talking about. It's too much, please. Right.
Yeah, the Rayleigh criterion is the diffraction limit of light based on the aperture of the human eye. Basically, it's saying that after a period of
And then it
distance,
doesn't apply
light
when you pull out a camera.
won't be resolvable with detail in it. This is based on the angle to it and the distance to it. This is where the 1.22 comes from. It's the distance and the angle of the slit creating the 1.22, which is basically the resolvable edge of light at a certain size and a certain distance. So they come
you are
up with
talking about the
1.22.
globe light. Are you talking about the reality? Or are you talking about?
I'm talking about reality, light coming into the eye, how they came up with the Rayleigh criterion, and how I can calculate the distance
Not
to
how
the
they
horizon
came up with
using
it.
it.
The Rayleigh criterion's a freaking Taylor expansion, infinite series.
So please tell me what it's used for, Ruhif.
What the Rayleigh criterion is used for?
Yeah.
Yeah, to work out the angle between two point sources of light that is unresolvable.
It's the distance to resolvable detail, right? It has nothing to do with two objects. You can take a pen, and the pen will walk away. You walk away with the pen. Eventually, the pen will diffract because the angle coming off of the wavelength of light will be too acute to resolve the information. That's how you
Correct.
get diffraction. Okay, that's all it is. So I just did in real time using the Rayleigh criterion. Did calculate the distance to the horizon. No Earth curvature formula needed. Ruhif,
And then as soon as you have a camera,
go back and listen.
you get a different
Go back
result.
and listen. Go back and listen. I just did it in real time with the
And then
math.
as soon as you get a camera, you get a different result.
What's the result difference?
You get a huge angle. Like, where are we? Where's mine?
You compress the angle. You just narrow the angle down, dude. You're still subjected to the 1.22 diffraction limit because it's based on the wavelength of light.
Yeah, the 1.22. I'm not disputing the 1.22. I'm saying the angle that you get at the end.
All you do is narrow
far
it.
smaller.
You've just narrowed it. That's all you've done. And to get a narrower light, you need to
Yeah,
open the
and you're
aperture
using
for more
that angle.
visibility. But you're still
using
going
that
to be
angle
subjected.
to try and work out the distance to the
You're
horizon.
still going to be subjected to diffraction, my friend. It doesn't change the diffraction factor.
You're using that angle to work out the distance to the horizon, and that angle.
Ruhif, does it change the diffraction factor?
You're using that angle to work out the distance to the
diffraction factor?
The 1.22 is a constant.
Does it change the diffraction factor? So all
The
your argument
1.22 is
your
a constant.
argument is moot. Your argument is moot then because you just said it changes on camera. I just asked you if it changes the diffraction limit. You just said no, it's a constant.
No, I said the 1.22. I said the 1.2.
Make up your mind. Make up your mind.
I said the 1.22 is a constant, but if you change the aperture size, like using a camera instead of your eye, you get a different angle. And you're using that angle to try and work out the distance to the horizon.
Show me the math. How does it change the distance to the horizon? Show me the math.
The Rayleigh criterion has nothing to do with the distance to the horizon.
The audience have to know more.
It has everything to do with the available angle and the resolvable detail to that angle. That's what the Rayleigh criterion is about. Nothing to do with what you're feeling.
It is about resolvability. It is not about the distance to the horizon.
So I just calculated the resolvability to the horizon using the Rayleigh criterion. No Earth curvature.
And then if you use a camera, you get a different
Show me the math,
number.
Bro. Show me the
got
math.
The formula.
So wait a second. You use a different lens, and therefore the distance to the horizon changes. Is that what you're saying?
No, what
changes.
That is me showing that your argument is stupid.
What changes,
the distance to the horizon doesn't change.
What changes, Ruhif? What changes?
In using a camera compared to your eye.
What changes? Yeah. What changes?
Just the resolvability, not the angle.
So you're compressing your resolvability. You're compressing your resolvability, narrowing it down, and you're opening up your aperture suit because when you narrow the light, it gets darker. So you need to open your aperture to see more available light to see the narrowed angle. Correct?
How about we can finish this in one question?
Okay.
All right. Does the angle to the horizon change? Does the angle down to the horizon from eye level, does that change depending on whether you're looking with your naked eye or with a camera?
The point is that with our human eye,
pretty clear yes or no question.
With our human eye,
you can never get an answer.
Yeah, I think this is pretty pointless.
Human eye,
it's too difficult to answer.
With the human eye, you have a limitation. You want to run away from the human eye and talk
Just you roboting.
Which is fine.
Hold
I'll
on.
gladly talk to you. That's it.
Hold on,
That's this
you're
argument.
roboting there,
It
mate.
ain't about anything else. It's all about angles. Yeah, I might be losing the signal here. Anyway.
Are you saying the camera always standard refraction from the camera? Are you saying that?
So,
Say that again.
the human eye has limitations to angles. Cameras have limitations to angles.
Yes.
There's the limitations to the diffraction. There's limitations to the wavelengths of light. There's a calculation for that available information.
You talk too fast. You're saying it's limitation for the light. Say it again.
Every diffraction limited system is subjected to the angles of visible light. Wherever it's bouncing off of, they're subjected to it. Those angles are calculable using the Rayleigh criterion. You can throw in a zoom effect or a zoom factor into the calculation, but it doesn't take away from the fundamental root that it requires or it is limited to angles. And that's how I can calculate the distance to the horizon, is because the human eye is limited to angles.
Okay, does the distance to the horizon change depending on whether you're looking at it with your eye or with a camera?
So the distance may optically look different, but no, the distance will be the same.
It doesn't change, right? So that's it.
Yes, because it's a 1.22 constant based on the 450 nanometers. That's how cameras are made. They're based off of the Listen, if I used infrared light, I could see farther, bro. The wavelength of light stretches farther. Same with refraction. The shorter the wavelength of light, the more refraction. The longer wavelength of light, the less refraction. There are effects with wavelengths of light that you're not accounting for. You're ignoring it. And it's the same reason why I get into why basically Ranty's doing the best thing possible, which is taking a break from this bullshit. Because at the end of the day, he's done enough evidence to substantiate there is something wrong with the calculation of Earth curve, bottom line. There's a major lack of understanding when it comes to even vision, and it's documented daily here. There's only so much you can teach somebody. Hey, by the way, the apparent junction of the sky and ground, it's not a real physical.
Oh, he's gone.
Yeah.
Oh, geez, that's unfortunate.
I have to say, we don't need all this. We don't need all these words. We don't need all this technique to know we have flat horizon. There is no bending horizon. Everything.
Sure,
is
the
flat.
statement that the distance to the horizon doesn't change from an eye to a camera is correct. We've all seen those videos where you just hold on, where you hold your camera and you focus on. You zoom all the way out, you focus on something, a boat or something that you can resolve, and you pull back and the boat seems to meld into the horizon. Now, the angle to the horizon doesn't change, but what you can resolve changes.
Excellent.
In my opinion.
Can you say it again? I didn't hear it. Can you repeat the last word?
The last word was the angle to the horizon doesn't change, obviously, but the what you can resolve on the horizon and the distance to the objects that are resolvable changes.
Yeah. So Flat Earth Data is using the imperial formula for calculating the distance to the horizon, 1.22, blah blah blah, whatever it is. And he's just happened to notice that the Rayleigh criterion also has the 1.22 constant in it, and he's just decided to conflate the two and decide that.
Again, that's a lie. Again, let's do the math.
Absolutely what you're doing.
Let's do the math. 1.22 times 0.00.
You can do the math. I'll go and grab a drink.
Stop rumpus me. This is the Rayleigh criterion in use to calculate that. This is not camera optics. This is human being optics. Okay. There's another zoom factor that you can add in to the angle. The point is that our eye will have a calculable distance to resolvable detail. This is why you have a compression point. This is why you have things moving in to the point of your eye. It's because your eye has a circular slit, which actually we'll see in a cone shape. And then you have a refractive part of your lens, which actually focuses that cone shape into a focal point cone shape. So imagine two cones in opposite directions overlaying. You have your refractive lens of your eye creating a cone shape, and then you have the circular aperture of your eye absorbing things through a cone shape. These things, the angles to which this light coming in is calculable, which is 1.22 times 0.000005 divided by 0.005 equals radians 0.000122. We want to take the radians and we want to turn it into degrees, which is 5 times 57.3, which equals to be 0.0069. Okay, this is what, according to Encyclopedia Britannica, in their physics course, because this is where I got it from, this is basically, you can take the 0.0069 and you can times it by 3.14 divided by 180, times it whatever distance it is, and you can calculate the size of the Aries discs, it's called. So basically the calculable size of the blur. Okay, you can do this with that formula. So what I noticed is that I ended up with 0.0069 degrees. Okay, I was like, quite interesting. Well, what's the distance to the horizon for a 6-foot observer? Well, it happens to be around 15,800 feet. Well, if I divided that by the tangent of that degree, what do I get? I get the 24,989 miles. Why is my Rayleigh criterion calculating the distance of the circumference of Earth? I wonder if I can calculate the distance to the horizon, obviously. So you just back calculate the which is 15,842 divided by the tangent. Or sorry, no. Anyway, you reverse calculate to get the numbers. The point is that the 0.0069 ends up in both calculations. Whether I'm calculating the size of the Earth, dividing it by the horizon distance, I'll end up with 0.0069. And same with the Rayleigh criterion formula. So what are the odds that the resolvable detail is calculable using the Rayleigh criterion, but so is our horizon, which is, by the way, an apparent effect. Well, that's what the Rayleigh criterion. That's what the Rayleigh criterion is. It's an apparent effect because the object is actually not blurring out. It's
Everything you're saying.
It's just you and your vision. That's it.
Effect, yes.
It sounds like you're onto something, Flat Earth Data, but with all these numbers and stuff, it's almost like you need a couple slides to look at, or
just write it. Write it down. It's real simple, man. The point is, if you go to Encyclopedia Britannica online and take the physics course, they will teach you about the resolvable detail. They call it 7/1000ths of a degree. So basically, like, we're looking at a hair on the ground. How far away can we see that hair on the ground? Right? They're calculating the resolvable detail based on the visible wavelength of light.
But now
there's a question about this.
We don't need it.
Anyway, if you go to Encyclopedia Britannica, go take the course, go understand how to calculate resolvable detail. What I found out is that the Earth curvature calculator says that at 1 foot high, that means everybody on this channel listening, anybody in the chat, anybody listening online, 1 foot, your head is 1 foot off the ground. The horizon, the edge of the Earth, the apparent junction, according to the definition of the horizon, is at 1.22. Stop talking, whoever's fucking talking. The point is, at 1 foot high, you have a horizon that's 1.22459 miles away. This is your geometric calculation. This is not based on the Rayleigh criterion or based on resolvable detail to the human eye. This is a conflation of the human eye and its diffraction limit. That's why I can calculate the distance to the horizon using the Rayleigh criterion, because it has nothing to do with the ball Earth and everything to do with available visible light and the angle to it.
Yes. But we know that they're hijacking perception, the way we see things, and turning it into
perspective.
A ball.
Yeah.
Perspective. Thank you. I think you're on to something. What was the name of that course again, just in case anybody wants to go check it out? It's Encyclopedia Britannica. What?
Physics course, Physics 101, the Rayleigh criterion. They walk you through it. Basically, they give you an exercise of a king back in the day who was fighting a whole bunch of people. He said that he could see 34 miles out or 34 kilometers out. And he could resolve 9 feet these blur. Basically, the point is they told a story around the Rayleigh criterion. They used the standard 500 nanometers with the standard size of the eye, which is 4 centimeters, I think, 0.4 centimeters, and they calculate it to meters. You get this 0.0. The point is if I take the distance to the horizon, the size of the Earth, and I arctange those two numbers, so arctangent 15,842 divided by 131,877,000, whatever the size of the Earth is in feet, you end up with that 0.0069. So one is obviously based on optics, and the other one is based on geometrics. So it's complete hijacking of the vision of our eye.
The point is, no one gives a shit about the distance to the horizon except Al-Biruni and you.
Wow. I thought, no, now you're
I give a shit about the horizon.
I don't.
Especially when it disproves your ball, 3969, 3959 out of the water.
Well,
Is it
no
another
one
69?
looks at the distance of the horizon. No one cares about it, really.
Well, you used to, but now that we're
so
proved that it's
yeah.
wrong,
Yeah.
I guess you don't want to
Crow,
talk
You're
about
not
it.
care about something
Crow,
that hurts
may I
Horizon,
interject? May I
only
interject here?
Al-Biruni used it.
Crow,
Only
your argument-
Al-Biruni.
Crow, listen, I don't think you understand the implications of what you're saying. You
Unless
may not
you're
care
honest.
about the horizon.
Did you get my statement?
Hold
Can
on.
you deny my
Listen,
statement? No, respond to my
listen,
statement
listen,
first. No, I'm not
listen,
listening to you. No, I'm
listen.
not listening. You've been teaching.
If
You've been
you
like
have no, if
No,
you
I'm not
have no
listening.
radius,
I'm
you
not
have no
listening to
radius.
you. You've
You
spoke
have
enough.
You have no
Respond to my
radius. You
statement
have
first,
no
and
2
then you
pi
can talk.
r.
Okay, let's.
What did you ask me?
Randy?
Okay, hold on one sec. Let's listen to what Crow's got to critique. You've got something to say, Crow. Go ahead.
Yes, I said no one gives a shit about the distance to the horizon except Al-Biruni, who measured the radius of the Earth through the distance to the horizon. Now, everyone else been using the other method to measure the radius of the Earth. So who cares about this?
That's the exact opposite of what.
Here's the
Dem-
point. Here's the point. Here's the
Kosho
point,
will tell
Crow.
you that's the opposite story that has been going around, that Al-Biruni didn't use the horizon.
No,
So you guys don't even have your story straight, in my
This
opinion.
is new. This is new because we squashed their 3950. The first time I hear this from Crow about Al-Biruni.
Actually, hang on. Before
Al-Biruni is
Crow
the only
reveals,
one who used the horizon. He's the only one. Tell me about
Well-
any globber who said anything else than that.
well, hang on, please. Before Crow reveals what the other method is, can any flat earthers here think of?
No, let's stay on track.
Method?
No, let's stay on track. Let's get to the
With all due
bottom.
respect, you
Can you
guys
think
have
of a
been
different
using
method
that
outside of Al-Biruni's method?
Al-Biruni for years, for months. Al-Biruni, he did this, he did that. And once we killed the Al-Biruni 3959 because we said there's no way he could have measured it because the horizon changes from the moment to moment and it's apparent. Once we established that, then you guys went on this Al-Biruni is nothing.
Right.
You're throwing him under the bus like Tyson, right?
No,
What was
I'm
Al-Biruni-
just saying he's
Does
the
anyone know
only
what
one who
Al-Biruni's
used
result
the
was?
horizon.
No,
what is
you
the
guys
method?
have been using it for years.
What is the method
What
used
was
now?
his result?
Ruhif, if you were to go out tomorrow, what is the established method that you would go out to measure the sphericity of the Earth and the dimensions?
To measure the radius or the actual shape?
Radius
Radius.
and shape.
Okay.
I guess
I
one is
would do what they
inherent
did.
within the other, right? Whatever Crow is talking about here, the Al-Biruni method is left behind. What is
Yeah,
the,
Pete, I'm interested
what
in
they
the
did
second
before
one,
was-
what he said.
Was
The other method.
measure the distance between latitudes.
latitudes?
Yeah, that's what they
Latitudes
did
are
to measure the.
imaginary lines of demarcation.
Yeah, but you point at fucking Polaris and you've got an angle, right? That's your latitude.
What?
It's all geometric bullshit.
Hang on,
that they
please. Hang on,
hijack perspective.
Hang on, please. Hang on, please. You're after saying there that you point at Polaris and you get a latitude, but you use a latitude in other calculations because it stands alone, right? It's foundational, fundamental. But it's going to be fundamental when you assume a sphere. If you don't assume a
No,
sphere, where
you
does that leave
asked.
you?
I asked you, am I determining the radius or determining the shape?
Well,
You
so
said the
both,
radius.
right? So
I'm
Crow
measuring the
talked
radius.
about Al-Biruni's method out the window. So Al-Biruni
Yeah.
determined that we lived on a sphere of a given
No, he
radius.
measured the
so I guess
radius.
the same thing
No,
applies.
hold on. Let me correct
You
everyone
measured the
because
radius.
everyone is speaking for me. I didn't say
Fair
Al-Biruni
enough.
is nothing. I said he's the only one who cared about the horizon. He's the only one who measured the radius of the Earth by looking at the horizon. No one else did that. That's
Okay,
all I
what's
said.
the other method, Crow? What's the other method that you were saying?
Elevation angle to the sun from two locations on a great circle.
Okay, everything assumptions. Great circle, length of
Yeah.
size of the
You
sun,
guys keep
distance to the
saying
sun,
assumptions.
all assumptions.
Well, you
guys keep
asked.
saying assumptions.
You didn't ask how
Crow,
I determine the shape
Crow,
of the Earth. You
it's
asked
very
how
easy,
I
but
measure
listen,
the radius. So I answered the
Crow, it's
question.
very
Right,
easy.
you didn't measure
again,
though.
Again, it's very
I
easy
did.
to fudge. It's
No, you
very
didn't.
easy to fudge. It's very easy to fudge your numbers if you're calculating for a sphere. For instance, if I take two observers they're 2,600 miles apart, and I take 395 divided by the distance between those observers, I'm going to get a different angle that I could add to the observer's angle, cross-calculate it, and get a farther distance to the sun. So it's all on how you're applying your presuppositions, Crow.
Yeah,
Can you please
even if
tell
you
me?
sneeze, you'll get a different angle. One
No,
sneeze
exactly.
at 2, angle up.
It's virtually at infinity for me, for my calculation. So it doesn't matter. The radius will be always the same no matter what I do.
So the thing
Oh,
is
wow,
that you're
that's
using
super
one
credible.
radius. You have to prove it exists first. Now the thing is what's a radius, Crow? Is it a straight line?
6,371 kilometers.
So it's a
And I
straight
came up
line,
with
right?
6,320.
So a radius is a straight line, right? So radius is a straight line, right?
Yeah.
Yeah. So can you have a radius of the Earth be on a circular disc the same radius on a ball?
I don't understand what you mean.
Can I
He's
have
talking about the AE map.
Can I have a radius the same size as the ball Earth?
I don't know. You should ask a flat earther. I don't know what you're talking about.
Well, how about a diameter? Can I have the diameter be the same? Can the diameter be the same on a sphere as it can be on a flat circle?
Well,
Yes.
Wow.
Are you talking about the flat Earth map?
No, I'm just talking about geometry, period. I'm not talking
about
about no
general.
math.
Yeah, but are
You're
you
talking about
applying
the
it to a
math.
flat disc map?
Okay,
Can a
awesome.
circle have
So-
the same diameter as a sphere? It's a simple
That's right.
question.
Yeah.
Awesome. Good to know. So please tell me where this radius is on your ball Earth. If a radius is a straight line.
From the center of the Earth to the edge
So
of
can
the
you?
Earth.
So how did you calculate the center of the Earth when man's only dug 8 miles down?
I took a flight from Qatar, Doha to Auckland, New Zealand. I measured the
How does that prove it's a
distance,
ball?
and then I measured the angles to the sun on that two locations. I got the radius accurate, 1% of error.
So you
You
measured
define
the
what the
radius.
sun is, right, and its distance.
You're presupposing the distance to the sun.
Hang on, please. You have to have predefined the sun size and its distance to come to those mathematical conclusions, Crow, right?
Don't care about the sun size. I care about the
You
distance.
have to have taken them into consideration, otherwise it can't work. Antti has shown here on his own channel that when you use the solar filter, the sun diminishes down into a tiny ball. Not to mention what happens when you get beyond the atmosphere above.
He just said he doesn't take into account the size of the sun.
It's imperative you define what the sun is, Crow, and stop bullshitting us.
He just said he doesn't use the size of the sun.
He uses the radius of Earth. You still have to prove the radius of Earth. If you're assuming one figure, you're going to have another figure come out. So if you're assuming something, then you're going to have whatever you want to assume to come out. It's putting the growing.
Holy shit, guys! We've been going an hour and I've not even had a single super chat. You're having a laugh, aren't you? Like, for real? Seriously? Right, okay, we've got 140 people watching. I decided to have a look at Fight the Flat Earth channel. This is for his last 2 streams that he did, 5 hours. 90 super chats from his supporters, guys. My last show generated $2.99 for 3 hours of content, and I've been doing an hour right now and haven't had another single super chat. And if you're wondering why these Flat Earth channels cannot survive, maybe it's because of this particular reason.
The relative location of the sun, not making any particular assumptions, right? The particular distances involved and the particular rotundities involved, but it's assumed at the start. Now, if we go to flat Earth and Crow is an open mind, he puts himself in a flat plane and imagines a rotund sky, a contoured sky. How can you say that the same results will not be the outcome, Crow?
Well, it's because of what you said in the beginning, which is very true statements, that there's the spherical sky, or the stars in the sky is around the spherical Earth, and so it doesn't matter if I take the sun, if I take one star at any declination, it doesn't have to be the polar star, and I do the proper setting for the experiments, I would get the same radius.
Yeah, but Crow, let's be honest. Without making that first assumption, you cannot make the rest of the mathematical calculation. You have to agree with that, bro.
Yeah, well, we were talking about the radius and how do we measure the radius, distance to the horizon. So, we're talking about something else now. You want to divert to how do we know?
Oh, no. If I miss, sorry, go ahead. I thought you were still talking about that.
No, you didn't miss anything. You just we were talking about the radius and how do we measure it and stuff like that. So.
What is that? When you work out all the mathematics there, so that is a substitute for Al-Biruni's calculations, erroneous calculations, unreliable calculations, right? So that gives you definitive results and gives you an Earth's radius every time via the mathematics and the empirical observations that we can all, no matter where we are on Earth, as long as we know our latitude and longitude, right, on a spinning ball Earth, we can all work out. True, Crow.
Well, of course, it's not accurate to some extent, and every method has its own, lack of accuracy.
Shout out to Lumberjack and Rob Keane, who smashed the super chat. Much appreciated, guys. Thank you.
They have to use They always have to use 2 pi r, which is Euclidean. They cannot use ellipsoid formulations to calculate. All they can do is calculate the eccentricity. They can't calculate the perimeter of an ellipsoid. So why do you spend all this time conflating your maths as a real thing when you're not even calculating for the real thing?
Is the Earth ellipsoid?
Your modern science says that it's an ellipsoid. You spend all of your life calculating for a sphere. Why is that?
Because it's not ellipsoid.
Okay, there you go. You guys heard it. Crow knows more than his own science, I guess. There you go.
Something is ellipsoid.
Well, as far as a look to images, it looks like a sphere. And the only difference is like 8 kilometers. Who gives a fuck about 8 kilometers?
Yeah, it depends how accurate you want to be.
So you just heard him say, who gives a fuck about 8 kilometers? Crow, why don't they have a formula for an ellipsoid if it's just 8 kilometers? Why can't they calculate? Why can't they calculate?
That's your claim.
Why can't they? Yeah. Why can't they calculate?
That's your claim. I can't confirm it.
Don't interrupt me. Why can't they calculate the perimeter of an ellipsoid? That's a question for you, Crow.
They can.
If they can, what do they use?
They can approximate it very well.
Oh, approximate it. Awesome. So this whole time,
there was a video on this like a few weeks ago.
All this time, you guys are using Euclidean 2 pi r when you should be using the ellipsoid eccentricity formulas. And you won't be able to do it because you won't be able to calculate it because it's not reality. Just like the 2 pi r 3959 radius ball is not reality. They are concepts, gentlemen. Welcome to Flat Earth.
Yeah.
Okay.
Can I ask? Are
the meaningless concepts, or is there some deeper meaning behind it? Is the truth known already?
No. What it was, everybody hated Euclidean. In the early dawn of astronomy, everybody wanted to prove Euclidean wrong. It drove people mad. His axioms and his postulates drove people mad. It wasn't until the 1800s that they came up with hyperbolic geometry, and then I think applied ellipsoid geometry until 1830s by Bernard Riemann, which now you have Riemannian geometry, which is spherical geometry, which is nonsense. It's metaphysics, conceptual coordinate systems. They birthed out of the 1830s.
No, that's not true, man. That is not true. I'm telling you, that's
1830.
That's not true because there's a contour sky and something moved in revolution.
1830. Yes, what Bernard said. He says, listen, at the local level we have to use Euclidean, but at the heavenly level we have to use elliptical geometry. This is coming out of Riemann's mouth. Okay, this is the guy who invented spherical geometry in 1830, coming out of his own mouth. Right. So everything in daily use are Cartesian, XY, 3D space, Euclidean geometry. Nothing is practical spherical geometry. Even plane flights are XY coordinates.
I agree with you, man, and I came to those conclusions a few years ago. I talked about them openly on my channel. But the point is here that the spinning ball Earth is metaphor. We know we live in a flat plane, a Cartesian grid-like coordinate system applies, but the spherical, elliptical considerations apply to the sky, which is where all the skylights, well, what reflect, if they're not the sun, in terms of the traditional material model, well, what is going on? So these are different considerations. So I think the maths can work, right? But,
the math. Okay, so Tycho Brahe, I think, is probably the this is the problem with Ptolemy. Ptolemy's argument, or Ptolemy's system, had issues with the angles to Venus and so forth. I think it's Venus. I could be wrong. Then Copernicus came out with his version because Ptolemy's was epicycles, which epicycles explained
Right. It was the retrograde motion of Mars, man. It was the apparent backwards motion of Mars in the night sky that couldn't be accounted for. And this is where we move from epicycles to the elliptical model, particularly made famous by, Copernicus, right?
I will go down to the surface and ask Crow a question. I will ask Crow about one thing. He thinks the horizon will dip down, the horizon don't go up to the eye level from the observer. Okay, in the long distance, of course, it can dip just a little bit down. It's sinking and everything. It can making difference in so long distance we are often talking about. I will ask Crow, see what he think the horizon will dip down how much it must to dip down if it was on a globe.
Depends on the altitude.
Okay. We take the standard 6 feet like a normal person.
No, I think the depth for a 6 feet person would be virtually zero.
Ruip admitted the last night, John Bernard, that over a flat plane, this is the opposing model that you say you've weighed up, right, both of you. Over a flat plane, you'd expect the horizon to rise to eye level.
Yeah.
As we look over, no matter what height you're at, it will always rise to eye level. And this is so when we look over at 6 feet, John, and we see a sort of apparently dipped horizon, and we view that as the horizon, which Al-Biruni did mistakenly, according to Crow now, has different methods, which prove the same thing, needless to say. But yeah, we understand as flat earthers that this is only an apparent horizon. And if we're to take Crow and Ruhith at their word, over a flat extended plane, the horizon will always rise to eye level. It's water all the way beyond. So when we see a target mirroring, we'll know it's in the zone of this mirrored water that will continue to rise from our perspective to eye level.
Yeah. But
have you ever seen mirroring at altitude over 100 meters?
Yes, of course you will. Of course you'll always get it, man.
Show me.
Well, bring up an image at probably over 100 meters. You'll always get it. Someone zooming into the horizon. You will always get it. It's like looking into a puddle. As you lower your perspective, you'll see a different sort of background setting reflection. As you higher it up, you will see a reflection of a different kind, but you'll still see a reflection. That's what's happening. Of course you will, Crow.
No, you have never seen it. I guarantee you. Or you would have.
Bring up Ruhith is here. Excellent, Ranty. Because this is the last week of madness. Ruhith and Crow, bring up Mount Canigou. And that's fucking well over 100 meters. And I'll show you the water mirroring.
Oh, there's a tiny bit, yeah. There's a tiny bit. There's still like 2,500 meters.
But hang on, Crow said it won't happen over 100 meters.
Okay.
No. Yeah, okay. Well, the one I have.
How much will the horizon top?
I take that back.
Down.
You take it back, John Bernard. No one can handle the dodo.
100 miles.
Canigou is one of the best observations of all time.
Have you number for that? You're on the globe, and you have to know how much in this distance and this distance. What can I say? 100 miles. Wow, it's very long distance. What can I say? 50 miles. Okay, 50 miles. How much will the dip down?
So, John Bernard, we can settle the question you just asked there. If Ranty will bring up for the audience the famous Mount Canigou image.
Okay, excuse me, PT. I am talking a very serious talk now.
Exactly, it's the same topic,
because
John.
the horizon we are looking to the distance, this rise to the eye level. We know that. Of course, it can dip down just a little bit because of density and the R and everything, but it's just so small. It's not. It's nothing for globe believers to take a benefit of that. You know what I mean? So
okay, John and Pete, I've just posted a picture in general. And guess what's the altitude of the observer for that image?
I don't say. I'll show something.
In general. No, it's just go to the room general.
Wind turbines?
Yeah.
Mirroring
I do
isn't
want someone to
always
bring in Kanagu, though.
right, but the mirroring isn't always in play, Crow, but immediately you are defeated and you withdrew your comment because in Kanagu, and if we go with your alternative hypothesis that the Earth is flat and the horizon will always rise to eye level over an extended span, then this water itself has to be considered as a source of the mirroring, which Ruhif and yourself will call inferior miraging within the
We've been
ball
through this
Earth
before.
thinking.
In the classical Kanagu image, there is a tiny inferior mirage of maybe 10 or 20 meters at Kanagu's distance. But then I showed you that image taken from a little bit further north, which actually has some land in the foreground. The base of Kanagu in that other photo is below that land.
It's fake.
Says that
okay. What image do you want me to look at, Crow? Is it the wind turbine one or the ones with the sticks in the ground?
Fake.
No, the wind turbine.
The wind turbine one's
right. It's not right lines you're taking there. The red lines is not right. What are you doing? I don't understand what you're doing there. Okay, explain it. Explain your photo and the general shot.
Okay, so the wind turbine is 98 meters and the observer height is 122 meters. So the hubs should be well below the horizon. So, but the horizon drops.
So when you take these photos, Crow, do you bother to mention the focal length of the camera?
Okay, right.
Like 50 mil, 25 mil, 40 mil, 80 mil.
Does it matter?
It does absolutely matters for sure, 100%. It changes your angle.
Okay,
absolutely.
what are we? Hold on. What are we looking at here in the image that I'm presenting? Tell me.
Yes, your elevation there was 120 meters, something like that.
Something like that, yeah.
Yeah, and the wind turbine is 98 meters. That's below your eye level.
Well, I don't know for sure.
So the horizon should.
There was a whole bunch of photos that I took up and down that hill. So, like I say, it could have been done at 80 meters. It could have been done at 130 meters. So I couldn't.
He's using your image.
Well, why does he say it's below eye level, though? Why are you saying it's below eye level?
It's below eye level because
that's not even the real horizon.
So what are we supposed?
Horizon.
Anyway, what's the
real horizon?
Yeah, but anyway, what's your point here?
You don't know that.
My point is at the final image when you were panning the view, that elevation is 122 meters, and when you were zooming out, the horizon was around half the height of the wind turbines.
Okay, so what's the?
I know. I see.
Hold on. No. It's my image. So hold on.
I know what's wrong.
So. Yeah, okay, so can you tell me, you think this is sky here, yes? In the background. You think that's water, and that's sky, yeah?
Yeah.
Well, then let's bring in Kanagu, which we've got a mountain, right?
Well, hold on. So if that's water and that's sky, can you determine that is definitely sky and not a culmination of looking through the atmosphere that's just creating a atmospheric blockage that stops you seeing any further over the horizon, an extended plane? Can you prove that?
Yeah, there's 3 targets. One of them at 40 kilometers, a light vessel, and 37 kilometers, the Hamilton platform, and 29 kilometers, that's the Douglas complex. All of them appear on the same line of that blue line.
So we're not seeing it on this image, though, are we?
This image is wrong.
That's why I said let's get Kanagu.
Right. So hold on. We're not seeing.
Yeah, sorry.
So we're not seeing. Do we see it on other images?
No, it's not in this image. But
right. Okay. So my question remains then: if if you are looking through a culmination of mist over a long distance, there's going to come a point where that mist stops you from seeing much further. And what it will have an effect of doing
I
is
agree. Yeah.
it will have an effect.
He's already responded, Ranty, right?
Yeah, no,
He
but
said
he's saying that
if
you can't.
pan around.
He's saying that you cannot see something that's 40 miles away.
No, I didn't
No,
say
he's
that.
saying
And
that you
yes, I
can
agree
see
with you.
platforms.
Oh, he did say it. Right, okay. So...
The fact you just can't see platforms in this particular freeze frame of your footage, right?
Right, okay,
Can
so...
I say what is wrong with this picture? Then you can keep on talking.
Go
How
on.
do you know there's no mirroring? I think Crow posted this picture to
No,
me,
I
right?
can.
How do you know there's no mirroring going on here?
Hang on. I just have to say what's wrong, and then you can keep on talking, okay? He is drawing the line in the wrong way. If you just put the line just a little bit wrong, then everything be wrong. And the water, the sea is boiling, and he's drawing the line in the wrong degree. So just if you do it from the start point, then it can be so big wrong in the long way. So
I didn't talk about the lines. I'm not showing the lines in this image.
What did you do? Is this from a video or is it from a still?
No, from the video.
Right, okay, because I've got the videos up now. So I'm going to scan through and we're going to be looking for what? Some complex somewhere?
Yeah.
Okay.
I don't think I would see it in the stream, so I'll go
No,
to
that's
the one
fine.
that I downloaded.
Did you not?
I'll just continue looking through and I'll see if I can pick it up.
Yeah. And I was just going to say, did you not post this image originally aimed at me, saying that you retracted it, saying that mirroring was not a thing beyond 100 meters? Is that not the? Am I looking at the wrong image where the two red lines are extending back into the distance?
No, forget about the red lines. It's just an image that I found easy, just in a hurry. So
what did you post that? How do you know? Okay, so let me just ask him. How do you know there's no mirroring layer here? Is it because you can't see it? How would you see a mirroring layer?
There isn't, because I've seen 3 targets.
Well, how? No, I'm talking about beyond the horizon. Well, it looks like the horizon is not the horizon. Remember, you're after telling me, after you leave your globe boots behind and you move into your flat Earth scenario, that the horizon, which is water over ocean, extended ocean at this level here, will always rise to eye level. So if we're not seeing it, well, no, but hang on, it doesn't look like it does, but imagine it actually does. And as we take perspective into account over the great distance, the water itself mirrors. But you can't see the mirroring there because there's no target to show up.
And we've just said, we've just explained that in other footage there are platforms and turbines and whatever else beyond the horizon, right?
Yes.
Why we're looking at a single image with nothing in the background?
So for Randy, at second 33 from the video, at the second 33, at the far left, that's the light vessel.
Hold on.
I've got photos through my auto level showing ships, like cargo ships, below eye level and beyond the horizon.
You guys are all discussing an apparent distance, and you're trying to tell the audience that you can measure an apparent distance. Do you know what I mean?
Flat Earth Daddy, you love this, right? So Ranty, after you're done, after we get this done with maybe 10, 15 minutes time, Ruhif is going to present a most famous of image, whatever one you want, Ruhif, with the original one, which is I think all I remember seeing anyway, or the whatever other one. And each man on this panel will be given, let's say, a minute and a half to give their best explanation from their particular point of view, and let the collective mind judge here in the panel and the audience judge. I should say it would take about 10 minutes, but I think it might be very fruitful.
You're talking about Canada, right, Pete?
Yeah, Dad. I said the image, the original image where it does show the mirroring. You said you had a secondary image. I'm not sure of that one, but I'll go off the cuff.
I'll try and find it. Oh.
You need my minute and a half. But in our own time, when Ranty has matched the image of what Crow's brought up here, I think that'd be a good exercise because we all have various and sundry points of view. And I think if you were to compress it in a minute and a half, it should come across quite clearly to whoever's listening. We're all looking for truth after all, right?
Yeah. We can go back to Ruthie and on flat Earth and the Google Earth and everything, it is but on flat Earth. If you really look it up, you will find it out yourself.
You have to place yourself when we see the image, John Bernard. You're up as well, John. I know you're a great mind. I definitely know that. So we have to place yourself in both camps. A ball Earth scenario or a flat Earth. There isn't really many other options. Concave Earth possibility, but we don't need to go there. And then we got to sort of snap between the two and make sense of the image. If we're looking over a flat plane, then we have to take it in this Z-axis extension, right, and explain phenomena which may hopefully come across as reasonable to whoever's listening. And then we also maybe have to consider the ball Earth. We're flat Earthers here, but the same sort of thing applies. We're about the truth at the end of the day.
Pete, it's not funny anymore. Everybody know they are working from flat plane, a flat map.
Yeah.
Everybody know it. Navy know it. The pilots know it.
Yeah.
It's a grand know it. I know it. I was sailing long way from Iceland to Portugal and to Spain and everything. I am educated. I will never take account for no fucking curvature.
Yeah.
Nowhere, anywhere, never. So
that means the real story is known then, John. That means the truth is known. And I don't like to think of someone knowing the truth that I don't know.
It's just a fucking bullshit and speaking. And Rohit, I know he's intelligent and everything. I don't know why
Rohit the bush kangaroo.
Why? Why is he talking against?
Rohit.
Why? I will ask him. Why are you talking against us? Are you paid for it?
Say again.
Are you paid for it?
Am I paid to talk about flat Earth? No, I'm not paid. Where's Wally? Asks Ranty.
Against. You're talking against.
What do you think about Wolfie's eclipsing geostationary satellites?
Wolfie. You take his name.
Yeah, I've still not seen it yet.
He's out.
Are you going to, Ranty, when you leave here, are you going to sort of take all your attention away? Are you cutting ties completely with all things flat Earth, globe Earth?
I'm going to have a very good break, I think.
Everybody know horizontal. We are living on a horizontal plane. You can't say the horizontal line is curve.
No.
It's nonsense. We know what we see. Oh, you don't not just know, we feel it. We feel it inside because we are one of the creation. We know it.
Right.
We don't have to
remember, John.
We don't have to get explanation for everything. We just know what we have to know. That's it. If you say it's wrong, then you have to come back. Imperial explanation. If you can't, then you have to shut up. Ruti.
Hey, Ranty.
Hey.
I did a little quick analysis of the picture that Crow used. Could I share my screen and take a look at it real quick?
Yeah, sure.
All right, let me share my screen here. Okay, so all I did was take his vanishing line.
How you doing, Brandon?
Hey, what's up, Pete? All I did was take his red lines were there. Can you see it?
Still black. I don't see.
Okay. All right, let me see if this works. Can you see that now? Yeah, I'll reshare. Hold on.
Not yet on YouTube.
All right, 1 sec.
Okay.
All right. Can you see it now? No? Okay.
I just see turbines. Is that?
All right, I'll just share the window.
I can see turbines now. The rain.
Oh,
has
you did see it?
Yeah.
You did see the turbines? Shit. Okay.
Not long as. Wait, no. Okay, maybe I am.
Tell me if you see it again.
Yeah.
Okay. So I don't know what happened there. Sorry about that. So all I did was take the vanishing lines, the perspective lines, and draw them out to the vanishing point based on simple perspective, out to what appears to be the center point of the picture. They align with what appears to be the center point, and they align with the vanishing point, usually terminates at the horizon. So I would say in this picture, the horizon is very likely much farther than this, and no curvature present based on these vanishing lines.
The point is the vanishing line should be on the horizon.
Yeah, it is on the horizon. You're assuming that this is the horizon. Look at this. Look at how much turbidity there is in the air here.
Exactly.
You can't see so long.
Okay, you see where your
Just,
mouse is? Move a little bit to the left side of the image, a little bit down, a little bit down. Yeah, okay. That's
Okay,
the light vessel at 40 kilometers.
Okay, you understand that that is the apparent horizon, correct? And you can see all the fog or whatever in the air in this picture, right?
Exactly.
And the
Apparent
fact
in
that we're
terms
already
of
seeing a very
refraction or
long
mist.
way. Well, what about these angles here, meeting up here towards somewhere? This should not be like this, Crow.
But they're not accurate, if you like to say.
Oh,
but
sure, they're not accurate. Sure.
So now these aren't accurate,
two
right?
little
Okay.
red lines were accurate.
No, come on.
yeah, that's why I've never talked about them. Just the first image that I found, I posted. It just was trying to find where the horizon. The image was too narrow, so I dropped it.
So your objection is based on this being the real horizon when it comes down to it, correct?
Yes.
Okay, and we all know that's nonsense because we don't see the real horizon. We see an apparent horizon. And very often we have observations that point to the horizon looking exactly like the sky, or the water looking exactly like the sky, where we see floating boats, etc. Correct?
Not from 100 meters of altitude.
Why not? Who says?
Do you see the light vessel on the left side of the image? Is it on the horizon?
Talking
or where
about
is it?
this,
And it's one target at distance. So do you tell me that 3 targets at 10 kilometers range of distances, all of them are sharing the same kind of phenomena? I don't think so.
What phenomena are you talking about?
And that
Sorry?
you just conceded on that one, Cole. Post a Canigo image where you see mirroring.
Show me where's the mirroring in that image.
Well, bring it up, guys.
We don't know, but you cannot claim that this is the geometric horizon, Crow. You just can't. We all know that's nonsense. You got to back off that.
Okay.
He has to with a ball, though.
Yeah. You know the picture where the boat is flying in the air? We've all seen this picture.
The one that I just shared a little while ago, yeah?
Maybe. So that boat is at a certain distance. If another boat at another distance, the phenomena will not be exact the same. The phenomena will be something different.
Of course not.
Okay, listen, hold on, guys. Listen one thing. Shout out to Neil the one for smashing the super chat. Who says thanks, Ranty, for your contribution to the FE debate. Thank you very much. Listen, I'm sharing my screen right now. It's a different image. This is a photograph that I took. It might be a bit clearer for you to actually look at rather than a second-hand passed along image that you snatched from a screen. So if you want to take a look at that.
Ranty, 10 seconds. Give me 10 seconds to Brandon, to answer your question. So, geometric horizon or refracted geometric horizon, what they must have is the visible horizon, right? Think about it.
Yeah, absolutely. And we all know that went out the window long ago, as they just threw Al Baruni under the bus not half an hour ago.
And they admitted it tonight via their sort of alternative to a whole Earth, an extended flat plane, where they admitted the horizon would rise to eye level. And if it does, well, this compression of water over this great distance, well, it will reflect. So when we see reflections and we see boats on the water at this great distance in relation to 100 meters, 300 short feet, well, then we can, the usual suspect will be the water always. So cheers.
Right.
Sorry about that, Ranty. Thanks for that.
Was everyone
worries.
listening to me type then? Sorry.
No. So what do you think of this image then? What do you see going on here if we zoom in a little bit? See these lines here? Do you think they would converge higher than the perceived horizon?
Yeah, of course. The last one is already above the sea horizon.
Mm-hmm. Does it look like there's any drop or anything going on here?
You mean like if I connected them, they should be curving a little bit.
Well, anything. Is there any
They
indication?
sure shouldn't rise linearly.
Yeah, I agree.
The pole, Crow.
Yeah.
It will not appear as a line. Yeah, I agree.
All right, I'm ready for Canigou, by the way.
Okay.
That sunshine, that sun image is very, very interesting and just proves the mirrored water layer over an extended span. But up you go. I think that's a great exercise. I suggested whether you take me up on that or not, that's your own business.
Right. So there is an inferior mirage like on the horizon there. Everyone agree?
No
Hold on. Are you sharing?
Oh, hang on, Randy's got to get up first.
No,
I'm not sharing.
So
can you share that image?
Which
in general?
Hold on.
In general.
Yeah. Hold on.
So, can I just say, Ranty, before Ruhif goes in, this is Ruhif. You got a minute and a half now to explain reality to the listeners, and there's about 6 or 7 people here. Everyone has an opportunity. So excellent. I hope that'll happen.
Right. So is the image up?
Yeah.
Cool. All right. So the angular size of the sun is 0.5 degree. The angular size of Canigou, which is that 2,784 meters high, and it's 233 kilometers away. That gives an angular size of 0.68 degrees, right? And this is taken with a rectilinear lens, so we can apply both vertical and horizontal angles. So yeah, the width of the sun is 0.5 degree, and the base, so 0 meters above sea level at the distance of Canigou, is at the bottom of the screen. That's where the base of Canigou is.
It's not the reality, just optic.
You gotta be
it's not
joking.
the reality.
You gotta be joking, right?
It's not.
Absolutely
What are you
joking.
doing, Louis?
Are you guys denying perspective again?
Okay, so
No,
hold
we're
on.
not denying perspective, Ruhif.
Okay,
You
so
haven't
what's the
taken
angular
into account
size of Canigou?
refraction.
Okay,
You haven't
so
taken
What's
into
the angular
account
size of
refraction.
Canigou?
right. Okay, so tell me. We
Take it
definitely.
away, Ranty.
Well, we definitely see an inferior mirage going on right around here. Would you agree? Firstly.
Yeah. Yep. How big is it though?
Yeah, I'm just saying, firstly, we see an inferior mirage. That's the first thing. Secondly, what you consider to be a hard horizon, to me, to my eye, doesn't look like a hard horizon at all. It actually looks quite jaggedy and a bit see-through. In fact, anyone could say that that's kind of not a solid horizon, where my cursor is right now.
It's not the reality. It's just the illusion.
Yeah, can you see where that's all jumping up?
Hang on.
All right, let me jump in just real quick, Ranty. Okay, so put your cursor at the vanishing line for the inferior mirage, Ranty.
Right here.
Okay, now
I'm
go
still
to
struggling
the.
to get your image up, by the way.
Okay, this is your image, Ruhif. We're looking at your image.
Yeah, no, but Ranty is presenting it.
Well, can't you pull it up on your screen in a separate window, bro?
For fuck's sake, I can't see Ranty's cursor on my fucking image, you idiot.
Oh, right, okay. Well, you know where the inferior mirage is.
Ruhif, there's no reason to call me a fucking idiot because I'm not one. Secondly, it wouldn't be too
reasonable
difficult.
people disagree with that.
Okay, it wouldn't be too difficult for you to follow along the listening to the words of my mouth and looking at the image and seeing where I'm talking about. It's not too difficult. Okay, so are you caught up now on the image on the screen? Can you see it?
I'm watching the image on the screen. On my screen. What are you pointing at?
Okay, Ranty. Okay, go to the far left, Ranty, because that's where I'm going to go. Go to the far left where the sun is inverted on itself. Okay, you see that, Ruhif, where the sun
Yep.
is inverted? Okay, that is the vanishing line of the inferior mirage. If you draw that horizontal across the Canigou, that's where the inferior mirage cuts Ganagoo, right?
Yep.
Okay.
Yep.
Now go just a little bit farther left of the sun, where you're in the sky on that same horizon. Okay, Ruhif. Now, where you see the water end, Ruhif, do you believe that right above where the water ends, you're looking at what you would consider the physical sky?
That the distance between the fold line and what we see as the horizon, the actual horizon is somewhere in there. It's hidden because of the inferior mirage.
Okay.
Yes.
Okay. So that's fine. But I would encourage you to consider that the horizon is actually at least up to, if not beyond, the fold line. Okay.
But you've got a mountain. You can see the mountain.
Okay, I'm talking about to the left of the mountain where you have the sky. Okay.
Yeah,
So
look at the fucking mountain, you idiot.
Okay, stop calling me an idiot, Ruhif.
You're being an idiot.
Okay.
Yeah,
No,
why are you doing that, Ruhif? That's really obnoxious, dude.
Simply because
I don't care.
Simply because you don't have the patience.
We have history. We have history.
Yeah, but I'm not crossing that line, so just chill out, okay? I'm not talking about the mountain just yet. What I want to get you to understand is that the horizon that you think you're seeing isn't the limit of the water. You just admitted that the water extends beyond that limit into the mirage. Okay? I'm simply asking you to consider the possibility that it extends even farther than you are comfortable admitting to. Now, we can go to Canigou. If you go to the fold line, if you go to the fold line of Canigou, that's the entire fucking mountain right there. The whole thing's
you're
right
denying
there.
Denying perspective. Yes.
No, sir. I would say.
How big is the angular size of Canigou?
Okay. That has little to do with the fact that
it is absolutely the entire point.
Ruhif. Okay, if you're going to say that I'm denying perspective, then I'm going to charge you.
Okay, then don't deny it. Tell me what the angular size of Canigou is.
Ruhif, I'm trying to talk and you continue to interrupt me. Is that because
you're just
you
fucking
don't
gibberish,
have
Travis.
confidence? It's
Gibberish.
not gibberish. Okay, no one else on my side thinks I'm gibberish.
It doesn't sound like gibberish to me.
Okay? You just simply don't want to critique the nail that you're trying to hang your hat on. Okay? You are accusing me of denying perspective, and I'm accusing you of denying refractive distortion. Okay? The one thing in my mind, the one thing that is dominant in this interpretation of this image is refraction, for which you cannot account.
Why didn't you let him get his minute and a half out though, Travis? And everyone
He wasn't,
Pete.
He wasn't going to do that, Pete. We're not going down that road right now, Pete.
Why not though?
Pete,
you just came in here and you're saying what road everyone needs to go down on. There's plenty of different views. So, Travis, let's bring you up in that point then. Is the mirroring of Canigou and the mirroring of the sun caused by the water, the extended water?
No, Pete. No.
How can it not be?
Can I say something? One times. I just want to say it's a magnification in the atmosphere that is making this picture. We can't prove anything. It's nothing to talk about. It's too bad image for the first.
John, Rayleigh is after admitting on a flat plane, the horizon would rise to eye level. Now, as we look at the apparent horizon, Travis is telling him this is not the real horizon.
Yeah, I don't care. I'm not using the horizon.
Excuse me, please. Let me finish my thought. As we go backwards, it's water all the way to eye level. As we see this mirroring, let me finish.
There's a fucking boat in the foreground.
As we see this mirroring, we can understand with our flat earth goggles on that it's water all the way back. And you'll notice that the mirroring line goes beyond Canigou itself, right? Because it's water all the way.
Do we all agree that the top of Canigou is where I've put the top of that red line?
No. It's illusion.
What are we looking at?
Illusion. We can't talk about it.
No, the vertical. So the
But
top of that vertical line, that's the top of Canigou.
We can say so here.
Visually,
It's so far away. It's so far away.
It's
more
apparent.
proof of
It's
flutter
apparent,
and
just
blue-
like the
blue.
horizon is. If it's apparent.
It's
And
apparent,
by the way,
no, it's
Travis,
nothing. It's a
it is
magnification. Magnification.
You can do your angle of degree and size all you want. The thing
That's
that you then
perspective. That's what perspective is.
okay, I understand that, Ruhif.
Okay, so where is the base of Canigou? Where is the base of Canigou? If there was no water in the way, where is the base of
Cut that
Canigou?
image in half. Cut that image in half. There it is.
What do you mean cut the image in half?
The fold line, Ruhif. I said this already. I'm not going to call you names, but I
Right.
said this already.
Hold
but
on.
You weren't listening.
Ruhif,
The
hold
fold
on.
line.
Hold on. Ruhif, do you have a image that we can compare to see what Mount Canigou looks like from this vantage point?
No, he doesn't. Because he doesn't
There you go.
believe that he has to have more than one image to do comparison.
Oh, there's stacks of images of Canigou. Like this guy, took
From the
dozens
same
of photos.
location? From the same location?
No. From
Okay, then
different
it
places.
doesn't.
You've got
Then that's a
stacks.
moot point. Okay, I could call you. I could call
So
you
hang on.
names right now, Ruben.
More
You're acting.
data is bad. More
I think
photos are bad.
Charlie, I think you're. I think I have
okay,
to.
John, hold on real
Can I
quick, John.
take over?
John, I'm sorry, John, just real quick, because I've got to do my paperwork real quick. Ruhif,
Okay.
I did not say more photos is bad.
Has he taken more photos? Yeah.
Okay,
Give John
Ruhif,
Bernard his minute and a half to explain what the fuck is going on. We've heard you a million times.
Hold on.
Shit.
Ruhif, I did not say that more photos are bad. I said that different photos are irrelevant. Okay, there's a difference.
Story, bro.
Okay, can I talk with Ruhuf now?
Go ahead, John.
Okay, thank you very much. It's no time. Okay, do you see this mountain behind, in front of this light, magnified light?
Why magnified? Why do you say magnified?
Because it's not the reality; it's just magnification. You understand?
Why do you say magnified? Why is this magnified?
In our reality, the sun is not big like that.
The sun measurably is half a degree.
Yeah. Okay. That's just
okay.
Talk.
So not magnified.
No,
not magnified.
Talking.
Zoomed in. He means zoomed in.
Zoomed in. Okay, we're zoomed in.
Yeah. And you see, it's very, very magnification in the atmosphere too.
No, there's not magnification in the atmosphere.
Okay. I have to take you step to step. What's happening there? But this image is not the best example to.
It's a fantastic image.
Okay, listen. Do we have?
Okay, but I can't do it. Can
before,
I do it?
yes, you can. Yeah, you can.
Randy, I'm not Randy. I will take him.
But whilst you're talking to him, I want some details so that I can try and find a comparable image to see what this mountain looks like from this angle. Whilst you're talking, so can you tell me where this was taken from, Ruhif?
That one says Martigues down the bottom. I'll give you the website I put in general chat like 5 minutes ago.
Martigues.
Can I just say that's why my suggestion is a great suggestion, because each and every one of us is given a minute and a half to offer their explanation for this brilliant capture of reality, what you'd see from a certain height. That's all you need to know at a great distance over water.
Right, so
go change the bands.
Yeah, but there's no right or wrong here. There's impressions, right? There's opinions, Travis.
Hang on.
Right, so hold on. Let's go back to John. John's been waiting to say his thing, so go ahead, John.
I just put a link in the general chat.
Everybody's taking my. I can never talk to the end.
That's why I've just said, John, go ahead.
Come on, John.
Shit.
Let me say something real quick.
No.
Okay.
Go on, John. Tell us what's going on with these images.
Okay, it's magnification in the atmosphere. Everything.
No, there's not. There's not.
He's got 90 seconds. Give him 90 seconds, Ruhil.
All right, 90 seconds, setting the timer. Hey Siri, set a timer for 90 seconds.
Come on, each and every one gets 90 seconds. Off you go, John.
Okay.
Twice and proud, John.
if you have the sun right above your head or something, you see the sun in the normal fashion. Then the sun fades away from you, it goes away from you, and it gets smaller. And in the more distance you go, something changes. Why? Because all the air and everything between magnify everything in the distance. So something you have in the distance gets bigger. And this sun is too big to be the reality. So it is the magnification of the atmosphere. That is fact. And men in the field that is working in this field have told us so too. No question about it.
By the way,
So-
John was a sailor, and he got that often at the port. So you said, and that thing is too big to be believed.
I am a sailor. I'm a sailor a long way, and I never meet no carpenter, nowhere.
I'm kidding, John. That was a great explanation.
Yeah, I don't know what. Listen, I just don't know what you're arguing about here, Ruhif, to be honest.
There we go. 90 seconds. My answer is the sun does not change in angular size during the day. There's no magnification.
Right.
Of course it is.
I guess your rebuttal. Ruhif has allowed a minute rebuttal, I guess, to anyone who makes flatter sort of attempted explanation.
I give a shit about that. Everybody listen to me, listen to what I have said. They understand it.
Yeah, excellent, John. You can shut up now. You had your 90 seconds. Ruhif,
Excellent. So my response.
I have
My response. The sun does not change in angular
90
size.
seconds now. What is that be front of this line?
Hang on, didn't you just have 90 seconds?
Is the mountains be front
well,
of the...
come on, John. You had 90 seconds. We all heard you. That was brilliant.
I get a chance to respond.
You
Right?
have mountains in the front of the light, the sun.
You've had your 90 seconds, right?
Yeah, he's had his 90
How far? Everybody.
So, hey Siri. Siri, set a timer for 90 seconds.
How far is this mountain?
Okay, your timer is set for 1 minute and 30 seconds.
Now, the sun demonstrably does not change angular size during the day.
Okay.
You can also show.
How far is this mountain? So far,
John, you've got to go on mute now and consider his response. Man. Come on, John.
Right. I've written on the image, it is 233 kilometers away from this location. All right. So we can work out an angular size. I've done this in a video, by the way, is to work out the angular size between the peaks. So ignoring the sun and taking into account the focal length of the camera to work it out. And that shows no magnification, right? This magnification thing is horseshit.
No.
The angular size of the sun does not change. It's
How can
half
you
a
say
degree.
horseshit?
The angular size of Canigou is 0.68 degrees. If you plot 0.68 degrees on the image
throughout the day, is that what you're saying?
It distorts when it gets close to the horizon from
You
refraction.
can't say horseshit. It's known.
Yeah, we have to respect the timer. Let's respect the timer, actually, because he has a timer going.
Okay,
Yeah.
so let me just make sure I'm understanding what you're saying, though, because never in my entire life has the sun ever looked that big at noon. Not once. So is that what you're saying? That it never looks different size?
Let's have some order then, Bob. Is that Bob Dole? Bob Dole, you can have your minute and a half trying to explain the image here.
I'm not trying to explain it. I want to make sure I'm understanding his claim properly. Because
Yeah.
that sounds absurd. The sun never looks that big at noon.
For a
It's
few
not
minutes.
the reality. It's illusion.
Right. Does everybody have to fucking talk at the same goddamn time?
Oh.
Like,
The
for
sun
real?
demonstrably does not change angular size during the day. It distorts due to refraction vertically when it gets close to the horizon, but not horizontally.
Not
So
horizontally.
you can find a picture of the sun looking just like that at noon. Is that what you're telling me?
As in, like, slightly squashed? No, it doesn't, because it's vertical.
No, as in that size.
What is
It's half a
what is
degree.
your reference
It's always
of the
half a
size?
degree.
Hang on, what is your reference of the size? What are you talking about? How can you tell how big it is?
Fucking measure it. It's half a degree.
You are fucking lying. I don't believe you anymore.
Yes, but Ruev has his own explanation. Now it's up to Victor. You can be next. Whoever can be next. Looking at the image, I think that's a fucking
Pete, this is
excellent
not your
image.
show, Pete. What the heck? Are you insane?
No, for us
Have you
all
guys
to give
never
our
measured the sun?
interpretation of it. We've all been in this a long time, and some of us are leaving it soon. So a
Have you
minute and a
guys
half
never
each.
measured the sun, angular size?
FE Core measured the angular side of the sun to be 0.5 degrees. FE Core, Dr. Zach and Steve
Listen,
Torrance.
a minute and a half each, and then Ruev and Crow.
Right, hold on, listen,
Come in with the
hold on, everybody be quiet. I want to just say hello to a few people that have turned up, right? So I want to do some mic checks, and I just want to get some other people as well. Right, okay, so Carlos, hello.
Greetings. Thank you for having me.
No worries. Chad, how are you doing? Right, okay.
Well,
so
Chad's quiet. I'm leaving at 9 o'clock, by the way. So.
Okay, no worries. Right, so Gleam, how's it going, mate? He'll be there.
Hello, Gleam.
Hello, Gleam. Helvetica Bold, how's it going, mate? Yeah, everyone's on mute. Chemo, how's it going, Chemo? Right. Hey. Right, okay, so Rumpus as well. Can we do your mic check as well?
Well,
hello. 1, 2, 3.
Okay, Randy, before
Perfect,
Ruev
right,
goes,
okay.
can I give my explanation?
Rumpus has taken my shift.
Yeah.
Well, hang on, Ruev, before you go, let me offer...
Your argument is just to demonstrate where the base of Canada.
1 second, please.
Correct, yes.
Oh, right, so you just it's 0.8 degrees angular size, do you? Just taking that from the top, and then you end up where the base is. Is that what you've done?
Yeah, 0.68, yeah.
Great.
Okay,
Yeah,
excellent.
perfectly valid.
Right.
And as he says, the sun never changes in size, so it's a perfectly reasonable thing for he's done.
Okay, thank you, Rumpus. Allow me my 90 seconds, please, before Ruev goes. And as Rumpus is here, who represents the body of science and beyond, this will be my offering. If you do me the honors, Ruev, of setting the clock for 90 seconds exactly, I'll do my very best.
Hey, Siri, set a timer for 90 seconds.
All of my experience, all of my thoughts, what's going on, and then you can rebut it.
Oh, just get on with it, Pete. For crying out loud.
Take it, Carlos.
Why? What's going on, man? All right, whenever do you want to go there? Okay, go.
No, you probably used 50
seconds. So I'm giving Ruev's explanation. Give me 90 seconds, please. So I know I'm about 10 seconds in. This is Ruev's explanation when he is on his flat earth shoes and he says, as we're looking over a flat, extended plane of water, the horizon will always rise to eye level. Because it doesn't rise to eye level here, as it seems to us, we understand that it's illusory, right? So we need to identify the real horizon. If we drew a line across where the sun starts to mirror, we'd find that it is behind, right, or above, right, from our perspective, the mirroring line where the mountains themselves start to mirror. As any object near in that mirroring layer will mirror below the further mirroring target. And this is what it's all about, target. It's all about identifying the boundary here, which is the real horizon, right, where the water ends and the sky begins, and this layer in between, which is water. And Ruev himself would have to make that case. It was water over an extended span, taking perspective and distance and compression into account. It's a mirror all the way, and that's my explanation, and I'm sticking to it. Thank you.
Can I have a question and answer show? Because that was.
You're pretty quiet though, Gleam. Speak up.
Sorry, man. 2 seconds. Let me try and turn myself.
You're still quite Gleam.
Is that better? Is that better?
Yeah, that'll do. Yeah.
A little bit. I can go more.
That's
no,
a lot
fine. Like you were messing up. Yeah.
It's a
I
lot
can go a little bit more. White mush. I'm distorted.
No, that's enough. That's too
Oh
much.
my.
You're loud and distorted as opposed to being quiet and not distorted.
Is that better?
Yeah, it's fine. Just go. Just go.
Yes, great. We can hardly hear you. Excellent.
Okay, number one, we know that on the horizon, even though I'm trying to forget the actual miraging bit here, on the horizon the sun bellows out width-wise.
No, it doesn't.
No, got that wrong.
It compresses vertically.
Yeah,
yep.
Which is
it changes vertically.
Yeah.
So it doesn't bellow out.
No, it doesn't. It compresses.
You guys are absolutely daft. You guys are absolutely
Jesus
daft.
Christ. It compresses vertically. No, it doesn't bulge outwards. Just the aspect ratio's changed. but vertically.
That's not
it
even the
changes.
sun. That's not even the sun. The actual
shit.
sun.
Oh right, right, okay.
It's an
Something else is
apparent.
very bright and circular in the
Yeah.
sky. Yeah, must be.
Okay, hold on
Never
one
seen that
sec. Before you go into too much back and forth, I want to share my screen because this is what was shown to me by Ruhif. So you was just talking about a big ball, right? What's this? This is the page that he's directed me to. What's this?
Yep.
What's that?
We're just getting rotating
They-
squares here. At least I am.
Yeah, what's that?
I'm just seeing rotating
Is that
squares.
2 images?
That's one image.
You reckon that's one image?
That's on one image.
I'm not so sure that's one image.
That's
really
one.
not so sure.
Rock Negra Martinez, Desmond, 14th of November, photo Alain Orange, and this is the image. Can you see?
Every image is true. It needs decoding.
Can you see? Ruhif, you've asked me to have a look at this page, and this is what it's brought up. What's that? That looks like two suns to me.
What's that there?
Really not sure that's one image.
It's one image. It says.
Really not sure about that.
It says.
Have you done a translate? Translate.
Hold on. It doesn't say it's two images.
Here we go. Translated from French to English. Here is a photo montage worked from 3 images from a rendering rich in detail. Come on, champ.
Well done, Ruhif.
Okay. Well, that's pretty awesome then. Do you know why? Because then that matches up to down here. Look, see? Can you see? That we're seeing all the mountain then.
That's not all the mountain.
That's not all the mountain. That's just the peaks of the mountain, you idiot.
All right. So how much are we seeing then, Rumpus?
You're seeing.
I think I worked out about 300 meters.
Well, who's talking?
That's better data. Your volume is low, man.
Who's over talking? Right, go on.
Yep.
So listen, you were calculating basically the axis of curvature, right?
The fuck is the axis of curvature?
It's like the next layer up to the axis of evil.
Oh, God.
Yeah. So listen, you're calculating the distance of curvature there, right?
Distance of curvature.
What the fuck are you talking about? Seriously?
What's the length of Canagoo? What's the length of it?
The height of it or the distance?
No, the length of it, not the height.
The height or the distance?
What's the length of it?
The width. The width. Left to
I
right.
mean the length of it.
West France. West France.
Yeah,
It's not an island. It's the whole land.
Yeah, it's you can measure it though. What's the length of that whole mountainous structure? What's the length of it or width?
What do you mean by the length? Are you talking about the width on screen? Is that what you're trying to say?
No, I'm just talking about the actual distance of the width, if you will, the length, if you will.
Mountain base?
Of the mountain.
Mountain base, okay?
Sure.
So
mountain base.
No, are you talking about how much we can see on the screen now?
Yeah, I think that's what he's saying.
I want you to tell me how long the base of that mountain is.
How long?
What?
From the camera.
In relation to how far we might be seeing.
What the hell does he mean by the
We're
length?
trying
How
to
long's
scale
a
it,
mountain?
Rumpus.
How long?
Listen, you guys have a horizontal image there.
Yes.
You're looking at a
Okay, so you are asking how wide is what we're seeing?
Yeah.
Sure.
But that's not the whole mountain.
I think I worked out it was
Where's the
about
horizon?
3 kilometers.
Calm down.
It was approximately 3 kilometers, I think.
So you're looking
I did that in the video.
You're looking at the distance of 18 kilometers according to the measurement that I just took.
18 or 3.
The base of the mountain is 18. Base of the mountain is 18 kilometers in width, if you will, or in length, depending on what we're talking about.
Quick.
If you're looking at that picture and you're noticing a horizon.
Stop giggling, you
said
freak.
Not 80, it's 3.
Can I finish?
We can't see the base.
Can I fucking finish, please?
Let him finish.
You're looking at a horizontal line with an island that has a width in it, and you're fucking calculating the angular compression of it when the width itself shows you that there's no curvature.
But hang on, the width and the height are settled. What isn't settled is the distance to the horizon line. How far is that, Ruhif?
So listen, you guys are calculating this based on curvature, but you're negating the y-axis. You're
Nothing he's done has been based on curvature. He just worked out the angular size of the mountain, and then he showed where the base would be from knowing the angular size of the height of the mountain. None of what he did involved curvature. Nothing of what he did involved curvature.
Fair enough.
All right, my shift has come to an end. Rumpus has clocked in.
Yeah, that's not true, Rumpus. That's not true.
You did a good job, Ruhi. You did a good job. Good turn.
Good.
I just clarify, Flutter Data, you're coming a bit low. Can I clarify the dimensions we need here, Rumpus? So, because you're after taking over. Very briefly, in 30 seconds, I'll do this and it'll clear everything up. Rumpus, as we look at that image, we need the dimensions, this is what Flutter Data is talking about, of the mountain span itself along the horizontal. We need the height, hang on please, we need the height of the mountain, right? And two other measurements. We need a distance from the observer, a fixed distance to the mountain itself, and the horizon line. This is the final fundamental distance we need, is the expected, or not even expected, the calculated, whatever, the distance to the horizon.
No, we don't.
So that's the most pivotal.
No, we don't. The only thing you need to do are the things that he showed us. That is, if you know the height of the mountain, whatever it was, that at that distance has an angular size of 0.68 degrees. Now you can see on the screen, because we know the sun is always 0.5 degrees, therefore we know what 0.68 degrees is on the screen with the image you're looking at, because we can just say,
well, hold on, let me...
Oh my God.
Was that taken with a solar filter?
Right, so we know the angular size, the angular height, sorry, of the mountain is 0.68 at this distance. We can see from the image what 0.5 degrees looks like. Therefore, we can create a line that's 0.68 divided by 0.5, and we can therefore work out the ratio, nearly there, the ratio, how much bigger that line is that he drew. Take that from the top of the mountain, and therefore we know that's where the base of the mountain should be, and we can see it's well below the water, therefore demonstrating there's an enormous amount of the mountain that's hidden by the horizon.
No, I will come in now. I will ask Rumpus. Nobody can talk now. I have to ask Rumpus. What the fuck are you talking about?
You're a moron. If you don't understand what I just said,
you don't know what I'm talking about. Okay, I'm not finished. Hang on.
You're too stupid to talk to me.
Hang on.
You are too stupid to talk to me if you didn't understand what I said.
Okay.
It's very simple.
I
you don't understand about angular size. You don't know about angular size, do you?
I'm so fucking stupid, so I ask you, what do you see on this image? What is this image? Is this image the reality, or is this different from?
Yeah, Randy, be a good host.
Something is happening in it.
Okay, well, hold
you're
on.
cherry picking some image that's not the typical reality.
We know.
You agree with me now?
The angular size of the sun is always.
You're not answering my question.
Always.
My question is, I'm talking about this image.
This image has got the sun in it. This image has got the sun in it, which we know is always.
Always, yeah, we hear that, Rumpus. Well, one sec.
Okay, you're not answering my question.
I am, because...
Is it always 0.5?
We then know the angular size.
You're not answering my question. I am asking you, is this the typical reality that we see the sun so big, like in this image?
It's not big, it's just zoomed in, you idiot. You can zoom in with cameras. Have you not seen?
Do you know what is happening in this image?
Have you never zoomed in? Have you ever seen a camera that can zoom in? Are you so isolated from technology? You've never seen the zoom in on a camera.
But you see, the sun is not the real shape. It's not the reality. It's illusion. This is just so far away.
What are you talking about?
I am not talking about this fucking image you are showing us.
This is a
not the
picture of the
reality.
sun.
Why are you cherry picking some fucking image that's not close to the reality?
This is a photograph of the sun, and we know that the sun has an angular size always.
Okay, I'm not talking about the angular size. I'm not talking about You know, it's a magnification. It's happening.
It's not magnified. It's always 0.5 degrees angular size, and the fact that it's big in the image is because it's zoomed in.
You're fucking stupid! You don't know that the sun is a planet! The sun is a far away from this!
Use a zoom lens! A zoom lens!
It's not in reality, it's illusion!
A zoom lens! Jesus Christ, it's not
Jesus Christ, you who are you?
I'm someone who's telling you you're an idiot.
He's the rumpus.
You never show me your face. What the fuck are
That's
you?
not going to change the fact you're an idiot, I'm afraid. You're still going to be as stupid as
You
you are
are-
whether you see my face or not.
You are nothing in my mind. You are fucking
Well, that's because you have a mind. You don't have a mind. You don't even know how to work out angular size, do you?
You have nothing to tell me because everything
Okay,
you
hold
say
on, John,
have nothing. You have nothing
Right,
behind it.
listen.
Settle down real quick.
Shut up. Right, everyone's being muted right now, so nobody's going to hear a fucking word that anybody's saying. Right. Yeah, you're going on mute, John. That's just not right. Here we go. Right. Rumpus made a claim, and I'm just going to bring him to task on that. I want you to look at my screen, Rumpus. You can see that I'm sharing paint right now. Okay, so I'm going to zoom in a little bit. So these are two images that was taken from the same spot. You can see layers, layer properties. So what I'm going to do is we're going to be looking at the mountain. So this is oh, hang on, wait a minute. So the mountain itself is scaled properly, right? But can you see the difference between, if I leave it there? So there is some glare. You just said, yeah, but we are measuring the glare with the image that is being presented by Ruhif. So you are measuring 0.5 degrees of glare, and I have just taken two images, lined them up, and showed that the difference in size is calculatable by a substantial amount. What do you mean, what have I done? Yes, I have. Two images. Yes. Well, when hold on. He said when glare is what did you say? When glare is accounted.
If you account for glare, the sun is always the same size.
Right. So when you account for glare,
have clouds and things
so
there'll be some attenuation.
So when we look at Ruhif's image that he presented, he was just showing a sun with glare, right? So how can you calculate the size of the sun if you were looking at glare?
Well, it's close enough. We can see, assuming you've done this properly, which, you know, given the fact you always get this wrong. But anyway, let's assume for the moment you've done this correctly, and this is two. I mean, I suppose there's a chance you've done it correctly because presumably the guy who took the photograph didn't actually change the zoom level. Well, I mean,
Ranty, there's no reason to let Rumpus critique you, Ranty.
Anyway,
You're not
so the
getting
point
hit.
No, I'm happy to let him stumble around this. I'm happy to let him stumble and stumble because.
Well, just let me finish then. Let me stop and be interrupted. Right. So the point is, let's suppose there is some glare effect here. It's changing the width by about 5% there. So that means that
5%.
Yeah, that's what I think. I think that's fair to say. The width is only different in those two by about 5%. So
I wouldn't say that.
Means, let me finish. So just take that we can go back and check that what I've just asserted in a second. But just let's suppose there is a glare effect of say 5%. That would mean that where he's positioned, the base of the mountain would be different by 5%. That still means there's a huge, great big bit of this mountain missing. And that is caused by the curvature of the
What
Earth.
was your claim was that the sun doesn't change size?
Correct. If you take glare
here, yeah, but here, and the guy isn't using a solar filter, and the image that's being presented by Ruhif is not used by using a solar filter. So we are looking at glare, And this is the difference that just
Yeah,
a little bit.
There's only a 5% error.
Yeah.
Okay, hold on. Let me jump in
This.
just real
Hold
quick.
on. No. Just a minute. On this image, there's just, in your opinion, 5%. I'm going to say closer to 10 or 15. But
You're wrong.
well, I'm not, because you're looking at it just one side. That would be 5% on that side, 5% on that side, and I'm going to say it's probably more. But anyway. The point is that this is just on this particular image. I haven't even analysed the other ones. What happens if we get another one with a bigger glare that goes even around here? What then?
Right, but let me jump in just real quick. Hold on, just real quick. Rumpus, I want to point out the fact that about 10 or 15 minutes ago, I said to you, you're not looking at the physical sun, and you laughed at me. Right now, you're conceding that there is glare, which means you're not looking at the physical sun.
Oh, I got your face, Rumpus.
Well, no, not at all. I mean, it was difficult to
yeah.
understand what you meant.
Not at all. Okay, look, okay, Rumpus.
Hold on.
Okay,
if you,
you hold on, Rumpus.
You didn't say glare.
No.
You claimed, I don't know what you were claiming because it was incoherent.
Yeah, you didn't know what I was claiming.
If the point you were making was about glare, then you should have used
ask
the word
for clarification.
Glare.
No,
if you didn't mention the word glare,
if you
that's
didn't
not
understand,
what you were referring to.
If you didn't understand,
if you didn't understand, seem to be implying that there was some other object or something.
Rumpus,
you did not mention glare. If you
Rumpus,
mentioned glare, we'd be in a different
Rumpus,
situation.
if you didn't understand what
mention glare, so
yeah,
clearly
Rumpus,
not what you were talking about.
Rumpus, if you didn't understand what I meant, then you had the full freedom of asking me to clarify. But that is exactly what.
No. I mean, I can't get you to explain everything because I'll be there all day asking you to explain.
Let me take this brief opportunity to double down on my position, right? Because we're all asked, and Rumpus, I'm looking forward to your explanation of the original image that Ruth presented. Remember, the image is true. We need to decode it. I'm going to double down, and if you can zoom in closer to the target, so that is where the sun is mirroring and where Mount Canigou is mirroring, I'm going to bet my bottom dollar that mirroring line of the sun is beyond, or from our perspective, slightly above the Mount Canigou mirroring line. I bet my bottom dollar to anybody here who is a man, and I'll tell you why, because it's water all the way. That's all I'm going to say. It's open to you, Travis. I was actually going to aim that at you.
Yeah, I agree with you. It's just not the water that's reflecting.
Well, it's over the water. The water continues beyond Mount Canigou, right?
Yes,
over
that's
extended
correct.
Flat plain. Rumpus would have to agree. Rumpus, with your flat earth shoes on, should the horizon always rise to eye level?
No.
Why not? Where will it drop to? If you're on a river and you're looking down at your feet and you look out over the expanse of the river,
on a flat Earth.
Yes.
On a flat Earth. Yeah. So if you have a sufficiently wide, sufficiently wide flat Earth, then ultimately it would rise to your eye level. Yes. I'm just doing the calculation on this 5% that I was saying.
And if that's water all the way, Rumpus, Mount Canigou, over water, beyond that is water, ocean all the way, there will be that distinct but clear line where the sun mirrors, because the water extends beyond Mount Canigou, and where Mount Canigou mirrors. Just likewise, if it was closer to Canigou, then a target would mirror line closer to our perspective, which is lower. Perfect.
I've just done an analysis on the picture. It's 9% the difference between those two images. 9%, assuming you've done that, you've overlaid them correctly.
I cannot speak here, or Randy cannot, I'm censored, muted, because I say something against fucking globehead like a Rumpus. Why?
Because you're a moron.
Because you are a fucking moron.
You don't have anything useful to say.
Okay.
You're the most.
Rumpus, these are not arguments. Okay, look at stop. You don't have arguments against John, Ranty, or me, or anyone else, and so you call us names. Knock it off. Man up.
No, I never ever just call people abuse. I always add in the point that
No. That's not an argument. You're just making a claim that you haven't backed up. Then, okay.
Rebut what I said.
It's an established fact.
No, it's not an established fact.
The angular size of the sun does not change if you use a solar filter. This is established scientific. Even Flatties. As I say, there's a YouTuber, a Flatty YouTuber, who took the took the measurement of the sun over a period of a year.
Chris Van Matry did the same
Ratty
thing.
love. You can speak how much because
using solar
it's like a ratty love you. He loves you.
Does not change over the period of a day.
I don't. I fucking hate you. There's nothing wrong with you.
You don't like having reality shoved down your throat. I know.
Everything you say is fucking bullshit.
The fact that you dispute.
Hey, you're a fucking science denier. Everybody knows it. You change what you're saying.
The sun does not change size over the
okay,
period
you
of
told
a
us
day.
the body of science. The body of science. You told us that. Body of science prove everything. Now you're saying the science proving it. Nothing. There's something wrong with you. You're fucking
No,
idiot.
I'm definitely coming to live with you in Iceland,
This is getting down to the fact about what science can prove.
We don't need this explanation for the millionth time.
Right, okay, listen. Everyone needs to be quiet for just a sec, because I'm sick of this back and forth right now. I have something really interesting to show, and I'm really pleased to show this, actually. It's better than I thought. I'm really pleased that Ruhif came in and showed us this. Can you look at this screen now, Ruhif, please? I've tightened it. Rumpus. So I've tightened it up even more, so I've been able to overlap it, pretty much spot on. Right? There we go. Can you see? Right? But what I want you to look at is, can you see the horizon down here? Can you see where the horizon is down there? And watch what happens when I put this image up. Now where's the horizon on this image? Ooh, look how much the horizon is risen on this image.
Well, you don't know the camera's in the same place.
Well, it is. They're all taken from the same spot, I'm afraid.
Yeah, from the same spot, but it could still be a different angle.
It's 320 meters elevation, and the distance to the mountain is 144 miles.
The angle of the camera.
The angle of the camera is not going to lift the horizon up by 1,000 feet or 1,000 meters. It's not going to lift it up by 1,000 meters, is it?
Which two photographs? Which two photographs? Where's this montage?
Right. Okay.
Are you denying there's a capture of reality going on here?
So let me put a line in so that you can see.
Randy Rumpus tells us that we can trust the ball Earth is a reality because of the pictures we trust from space. It represents reality. Are you telling us that this image doesn't represent reality? If we don't understand it in the proper context, that's one thing. But it needs decoding. Would you agree, Rumpus?
Well, I mean, when you have... I believe this image is interesting to people because there is extreme refraction. I believe this particular image is interesting because of this extreme refraction case, a sort of black swan type environment. So there is a lot of refraction going on. When you're talking about pictures from space, these pictures from space you're talking about, Pete, they do not subject to refraction because you're out in space. So the refraction issue is much more difficult on the Earth taking pictures like this. So which two pictures of these, Randy? Have we got this montage somewhere so I can see these things?
Yeah, the links in the general chat that Ruhif posted, the link to all these images. Now, what I'm saying is that the horizon, if I just take it on there and I stop it there, and then I flatten this image here, get rid of that, and now what we have is we have two distinct horizons. We have a horizon there on the image with the inferior mirage, and we have a horizon there, right there. So we have it scaled proportionally, but we have two horizons, and you can see it the same on this side too. You have a horizon there, and you have a horizon down here.
Where are you getting this other horizon from? Where are you getting that second one you just drew from?
Darker line.
That was the original image that was underneath it. That's this is there's two images, one on top of the other, right?
Yeah, well, I can't see. How are you? Yes, I can't see the other image. How are you? How did you line that?
Okay, well, you appreciate that I put two lines in, and you appreciate there's two horizons, right? At the moment. So let me remove. Hold on, let me remove all these lines now.
Well, hold on. No, you put them back because
there we go. Now
they didn't even line up.
Hold on, wait a sec. Image. Layers, so layer properties. Hold on.
Yeah, it's not horizontal.
Hold on.
It's not horizontal.
What do you mean what's not horizontal?
It's not horizontal. That black horizon's not. It's off horizontal.
Why are you screaming?
Christ.
What are you? I have no idea. What do you mean it's off horizontal? I have no idea.
How can it be horizontal on the globe, Rumpus?
My ears are hurting.
Yeah, what are you on about? This is lined up absolutely perfectly.
Well, that black line you just drew.
Uh-huh.
That black line, whatever it was not horizontal. There,
Right.
That black line in the other image is
Yeah.
not horizontal.
Well, you appreciate that the hill is lined up properly, yeah? Would you appreciate that the hill is lined up perfectly in these two images?
How do you draw a three-dimensional horizontal line on a two-dimensional image, Rumpus? How do you?
Ruhif, just let Ruhif answer, for crying out loud, Pete.
Okay, I'm sorry.
It's Rumpus, actually.
Right.
It's not. It's not far off. I'd agree. It's not. It doesn't seem to be that far off, actually.
Right. So I'll leave it there. Right. So now I'm gonna flatten the image so that I can put a line in. Get rid of that. Now I'm just gonna put the line in. Let's get this line here, and we're just gonna run a line through the horizon that we see on the top image. Right. So I'm gonna lower it down till it covers the horizon. Yeah. Would you agree that's about right?
Do with nudging up on the right side a little bit, but yeah, it's not far off.
Right, there we go. That'll do. And then the original horizon from the one underneath is there, right?
Well, I can't see that. No, I can't see that.
Oh my goodness.
It's not there. You asked me to say, and I can't see it, can I?
Right.
You're not showing me.
If you look at the edge,
You're asking me to tell you something's horizon, and I cannot see the image to which you're applying it. Jesus Christ.
Rumpus, look at the edge. You can see it at the edge. Just look at the edge. You can see it.
Now.
Right, there you go. Now you can see.
It before.
So now you can see that, yeah?
Yeah.
So now we've got two horizons, but the mountains are matched up. Why do we have two horizons, Rumpus?
Well, the refraction conditions are presumably changed.
Yeah, but that's good. So are you admitting that the horizon can change?
Well, of course the horizon
Right.
looming on. Looming moves everything, including the horizon. If the refraction conditions change, it will move the horizon.
Awesome. So when Ruhif presented this image and he said that, oh yeah, that there is globe earth proof. What happens when we move it all this way down here and we go all the way down to the,
It makes no
the
difference.
horizon
Scale,
here?
This is the thing you don't understand.
It makes no difference.
When you have a small error, it doesn't matter if you've got an enormous value, which he did with that 0.68, the line he drew, which was 0.68 degrees. It doesn't matter whether there is a little error here.
Oh, I think it makes a huge difference.
Well, we don't appreciate you don't appreciate errors. Then you don't understand how errors work. If you've got a big number like 100, and you've got a ruler that's only accurate to say 1 centimeter, you don't have to worry about when you're saying, oh, this is 100 meters long, because it's accurate enough. Whereas if you're measuring 2 centimeters, if you're measuring 2 centimeters with a ruler that's got an error of 1 centimeter, then you've got a big of a problem.
This is
why I asked him to, Ranty. That's why I asked him to scale it.
This is a very this little angle here. Just
much bigger.
let me finish. Let me finish. Let me finish.
Is irrelevant.
Let me finish. The line here that I'm putting in, that area there, that could be tens of miles. Tens of miles.
Yeah,
it could be 30 miles.
Here, Ranty. It's irrelevant.
Hold on.
Angular sizes.
This.
Do you not understand how
Yes, I do. But first, yeah, this is a case of.
Is irrelevant.
This is walking. Yeah, this is walking you through this, Rumpus.
No, you don't understand the difference between angular size and absolute distances.
Yes. With his 90-second clock.
How about just him letting me finish? Well, I'll tell you what. I'll let other people take over because I'm getting bored of Rumpus. Go ahead, somebody else take over.
Well, I mean, you don't understand basics about angular size.
Let me just say, hang on, please. Let me just say, Rumpus.
Angular size means.
Rumpus, he's after letting the panel take over. I'll be very brief. I agree with you, and it's very true. We have to be very careful, and this is why I asked you for a demarcation. And you remember, if you mentioned at the very start that the horizon where it was didn't matter, but as we're looking over the image at Mount Canigou at a fixed distance, the horizon is vital because you're explaining disappearance of Mount Canigou beyond curvature. So when you're after criticizing Ranty, justifiably, you have to look at yourself now, and from a flat Earth scenario, because that's the opposing scenario, you must consider as the true scientist, right? There's no other, unless concave or something fantastical like that, right? But flat versus globe, you have to consider the scaling of that z-axis. So if fundamentally we're seeing all the way to Mount Canigou and beyond, right, then that z-axis, which is 233 kilometers or whatever, has to be scaled appropriately. And let me just say finally, the ground, what we're looking over, the terrain, has to be considered fundamentally, and that is water in this case.
Utter gibberish from start to finish.
If you think that's gibberish, that's perfectly clear. The best I could do.
Pete,
anyway.
Okay, let's demonstrate. Do you understand what angular size is? How would you
Yes,
work that
of
out?
course I do.
Tell me. Okay, explain to me how you would determine the angular size of something.
Pretty much, if you draw a circle on the ground, right? So if you get a piece of paper, any one of us is capable of doing this. Get a piece of paper
I
and draw
want
a
you to
circle
give me
of
the
what?
formula for angular size of something, please.
What I told you, talking about the measurement. How do you measure the angular
I want you to give me
size?
a formula for the
Okay.
angular size of something.
Okay.
What do you need to know to
Okay,
work
the
out
distance.
the angular
You need
size
the
of something?
distance. You need three. I think. Let me think. You need a distance. You need the size of the object in relation to the distance. And what else? Would there be another consideration? I guess it depends whether you're looking at what the measuring instrument. That'd be another consideration. So how are you measuring the angular size of the sun via your eye? You could do it via your eye, drawing a circle on the ground, right?
So
A
if I gave you the
360-degree
distance to an
circle.
object, so let's
Hang on, please. What I'm saying is correct.
Well,
If
hold on,
you
let me
have
ask
had to
you.
do it
I'm about to
yourself,
give you the information. If I told you we're say 100 miles from, say 100 kilometers from something, and the thing is say 20 kilometers high, how would you work out what the angular size of that
fuck's sake,
object is?
Rumpus. I'm fucking educated man, right?
Well, then tell me what the answer to my
Right.
question is. If you're
So
educated.
you'd work out the fucking angle, right? So you have the opposing size, you have the opposing size, and you have the adjacent size, which is the distance.
You don't know, do you?
And you'd work out by the sine
You
of
don't know.
the sine of
Yeah, you
the
see,
angle
you
equals the
don't
opposing
know.
over the
You
adjacent.
don't
Oh, that's
know.
wrong.
It's a 14-year-old would know how to do that. You see, this is the problem. You don't understand the basics about geometry and
Shut your mouth,
trigonometry.
man. Let me think
And
about
when
it.
you
One more
don't
second.
understand the basics, then you can't
Okay,
argue
it's the
about this at
tangent.
all.
It's the tangent
You're
of
not in
the
a position.
opposing. Hang on, it's the tangent of the opposing distance over the ground distance. So the distance from you to the target. So the tangent of that will give, or the inverse tangent will give you the angular size.
Correct. Well done. You got there eventually.
So what do you mean then I haven't the fucking clue?
Well, you didn't.
I was trying to refresh my memory.
No, and you had to work it out. And because obviously the first
because
time
I don't
you've
think
ever done
about
this.
these things every day.
Well, you don't think
I
about
discovered
these things,
Aristarchus
and
a few years ago.
So you were trying to work out this thing with not understanding how angular size works.
Well, I got it right on the fucking second try.
It was a third factor, so you clearly had no idea what you were
said
talking
sine
about.
first
And
of all,
only
didn't I?
now have you actually thought about what angular size
Listen to
consists of.
me. I've said, not only now, I said sine first of all because I confused it with the opposite over the hypotenuse.
Yeah.
That's all.
Right, so
I
you didn't
understand how you get there.
But you thought there was a third factor. So
But hang on.
You've only just started to think about it properly, is what I'm showing you.
No, I haven't. You haven't thought about the third factor.
You didn't. There isn't a third factor.
Listen,
you didn't
okay.
understand
When you do your experiments, let's get on to your test you're going to do recently.
Well, I thought.
Hang on, please.
I think Ranty wants to talk about this. I think.
But just before we do, because
No,
it's a
I
good
wanted
lead
one
way.
question.
You have to consider two opposing points of view, right, Rumpus? As a ball Earth consideration, how might that, when you get all the results in, how might that affect, calculations? And then the opposing point of view, the flat Earth point of view. Have you extended a flat Earth synopsis to the best of your ability and what you would expect?
This diagram, this photograph that Ranty, Ruhif is showing us demonstrates we cannot be living on a flat Earth because a vast amount of that mountain is missing, and he showed you how much was.
But tell us your flat Earth scenario.
So we can dismiss the flat Earth model. That one image.
Hold on.
You said that the horizon rises to eye level.
Hold on.
Even allowing,
listen.
Even allowing for Ranty's
I want
that there is a little bit of error between the two images.
Yeah, I'd like to listen to. I'd like to try a different path here. So Gleam's waiting in the wings. Do you want to make your point?
Just Rumpus said about your mountains, and he says the reason why the horizon goes up and down is just standard lumen. It's that Lumen takes everything with it. And my question really is, why didn't the mountains go with it? Because he lined the mountains up.
Ding, 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 ding.
Different distances differently. So, for instance, things at greater distances.
It's selective, is it?
More. Yeah, that's right. Exactly.
No, wait there. That's a good point.
If you understood looming, Ranty, you'd know that things that are further away are loomed more.
So it could loom something up in front.
So you get confused.
So it could loom something up in front of something else.
Not in front of. It raises it, and if it raises it above something, it can appear. It doesn't bring it in front of. It just raises it. It just changes the vertical position. It doesn't bring things in front of other things. It moves them up and down.
That's the same thing, isn't it?
No, it's not. It doesn't. By looming can never bring an object that's behind another object in front of an object, is what you implied. All it does is it raises it up and down, and things in the distance.
I didn't imply that. I implied that.
Well, you said bring it in front of.
We've got the observer. We've got the middle object, let's say, which is the horizon here, and then we've got the background mountains. Okay, the mountains stayed the same. It was the middle horizon that moved up.
Well,
and
looming
then
will
moved
affect
down.
everything, but it affects everything differently depending on its distance from you.
But he lined up the mountains. That was the thing.
Yeah, and the mountain and the water are essentially the same distance.
Yeah, so that means that the mountain because it's further away than the horizon, means that the mountain would be loomed up. So if you did what you did, doing what you did, which was to hold the mountain. Just listen, try listening.
Would you do what you did?
He's tripping over his words now.
Here we go. You'll see how stupid you're being. If you do what you did, or did what you do, you do what you did, then you made the mountain a stationary point, and because the looming conditions were different, and you positioned the mountain in the same place, that would mean that the relative position of the horizon would go down. If you were to line up the horizon, then the mountains would be loomed more. So there were clearly different refractive conditions between those two photographs.
He's okay, John. Well, Ranty, if you stand by what you said, it's water all the way to the mountains fundamentally. That's 230 kilometers of water. If we see mirroring, it's going to be caused by the water.
I mean, Randy, you say that you've done lots of observations, and if you've done things like the Isle of Man, I mean, for instance, Anthony's observation of the Isle of Man, he had conditions varying in a few seconds where mirage. Well, I'm talking to Ranty. You can have a turn in a second. You'll have seen that in those situations, you interrupt. Yeah, you can have a go in a second, John. How about let me finish, then you can have your turn. Over a period of within seconds and minutes, you can have different refractive conditions when you've got this highly refractive, extreme refractive condition we have, I believe is the case with this Carnegie thing. And so things are moving up and down quite rapidly. So the difference between those positions of the sun, 5-10 minutes apart or something? So that in that time, the refractive conditions can change, and that will loom things differently.
Okay, so let's get Pete. One sec, Pete. So the final question I basically have on this is then, if you've just you've just turned around and said that basically there's extreme looming conditions, it can change in an instant, blah 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 blah. Why then is Ruhif showing this observation around and pretending that it's just a globe proof when, as in your own words, it could literally have been taken either extreme looming or something like that?
I think this image of Carnegie is quite famous for saying we shouldn't see any of the mountain at all, but because we can see some of it, therefore that this is used as an argument against.
You're fucked altogether then, Rob.
Oh my God! Yeah, can you stop interrupting me? And so the reason I think he picked on this picture was because it's being used as a sort of anti-globe proof and saying you shouldn't be able to see any of the mountain, and it's because I think at one time every year, for some reason, the refraction conditions tend to form in a way that means you can see the top of this mountain, which you shouldn't be able to see at all. So that's why I think this image is sort of used.
It's the sun providing the contrast in the background.
But if you were to take a typical, for instance, on a normal day, I don't believe you'd be able to see the mountains at all. So that's why this photograph is used as a sort of debating point, because it is a
the sunward setting providing contrast. Can you admit that, Rumpus?
Rumpus, let me ask you this.
Can you hang on, please? Whoever's speaking, can you admit that, Rumpus? It's the sun. You said it happens on a very rare occurrence. It's the sun in the background setting, providing contrast, the way we can identify the image.
Right, for a start, remember that it's in the evenings you tend to get these circulating rays or extreme refraction conditions. And this photograph, I believe, that of Carnegie is particularly famous because the mountain shouldn't be seen at all. And it's a case of really vast looming going on.
I guarantee you, it's as predictable as the. And let me just say this, please, and I'll go on mute. Rumpus, I guarantee you that. Can I just say this, please? John, 1 second. John.
Pete,
1 second, John, please.
Pete, if you see other photographs from that location.
I'm on point here. Let me just say this, Rumpus. I guarantee you that it's not random or chaotic. It's an annual occurrence, and it happens to be on its transit in and out over a flat Earth. The sun happens to set behind Canigou, lighting it up and giving us that contrast over the extended span. So it's as regular as clockwork as opposed to what you said. I bet you on that. Another bet.
It's just the conditions, the particular atmospheric conditions at that time of year, because there's a particular combination of meteorological conditions that tend to occur at that time of year that mean you tend to get, just like in the evenings in some locations, or for instance, Ranty's Baron Furness location, where he's got a body of cold water and he gets these shore-to shore observations. I really must research these a bit more. He tends to quite often get these interesting shore to shore observations, which you wouldn't get normally in other locations. But because he got this body of water coming in and warm air,
let me just say, as you're decoding that image,
to get these shore to shore observations, which are caused by strange refraction conditions.
Ranty was correct. You've never clarified your position as to exactly what the cause is for inferior mirages. So let me just get this clear, and I'll definitely go on mute. Rumpus. Just the second part.
Pete.
Hang on, please. Let me just say, you can bring that up with Ranty. Let me just finish the question, right? Are you telling all of us here, when we look at that image that Ruhib presented, right, and we identify the mirroring line for Mount Canigou, that when we look at everything above it, which is Canigou above it, that's not a direct image we're looking at. I say it is, but you're saying it's not, because we shouldn't be able to see it at all.
By direct image, yes, it's the
direct image. I'm looking at it. We can look at it with the camera. We can zoom in on it, like a duck on the water.
I mean, someone was saying earlier, the plain truth saying things aren't what they are, because we know that things like, if you go outside and you look at a tree that's 200 yards away, it's about 1/4 of an inch or 1/2 an inch higher than it actually appears, higher, raised up due to standard refraction than it actually is if you had no atmosphere. So similarly, so the sun, for instance, sets.
We always have atmosphere.
When you see the sun setting, or you see it touching the horizon, actually, it's most likely to be below the horizon already. And refraction means that you can still see it.
When we see the tree directly, Rumpus, as we point our finger to it, if we're 200 yards, hang on, please. As we point our finger to it and we walk towards it, as we picked up a certain spot on the tree.
I'm sharing an image. If you guys want to take a look, in the Discord.
Yeah, it's huge,
He's
Ranty.
denying our direct visuals, Ranty, and this is the crux point. When we're looking at Canigou, when we identify the mirror line, everything above the mirroring line with Canigou in mind, are we looking at it directly? So if we pointed our fingers at our jet boots and could go 233 kilometers, would we hit the target? I say yes. Rumpus, you have to say no. We're hitting midair.
Well, you're denying
these extreme circumstances we see it.
You're denying that light bends. I mean, you're an idiot. There we go. So it's not directly where you point. It's slightly affected. It's raised up. Just standard refraction means that everything is slightly raised up. Even trees a few hundred yards away by 1/2 an inch or so are raised up by standard refraction due to the fact that there's a density gradient. And similarly distant things like the sun is actually set behind.
How much is it raised up? How much is a tree raised up?
But refraction looms it up.
How much is a tree raised up over a couple of 100 meters?
I think, as I've done this calculation, I think it's about 1/2 an inch.
Sorry? How much? You cut out then?
I think it's about 1/2 an inch or something over a couple of hundred. I can't remember the exact.
Okay, and what about
it's a long time since I've calculated.
1/2 a mile or something like that?
Well, obviously that's getting on for a few feet or something.
So how do snipers account for this?
Well, they have to allow for refraction.
Yeah, I'm asking you, how do they do it? How do they do that?
Given the different refraction conditions, they adjust their sight such to allow for it, and they also have to do that obviously for the distance as well. They have to allow for the drop of the bullet, so they allow for lots of things.
Coriolis also, Rumpus?
They also have to allow for Coriolis if they're doing a 2-mile shot. Yeah, and this is if you can do lots of videos on YouTube, people of snipers doing this and actually showing you Coriolis tables.
No,
so if you go for artillery, and if you have artillery, of course, then there are absolutely you have to allow for it. So, for instance, in the First World War, when they started to have to allow for Coriolis because they were shooting about 10 miles.
Yeah, not Coriolis.
Ships, they had to build little sort of
not Coriolis. Somebody else mentioned Coriolis. Yeah, but somebody.
In the Second World War, they had even
somebody else. Let's get off Coriolis. We're not talking about Coriolis right now. We're talking about refraction. So, I want to maybe see a citation or something that says that military people or people that have used, sniper. Some of these snipers have been trained to account for refraction.
Well, they just stuff in the conditions. They got tables. They have to say if this is the temperature, then you make this change, and if it's something else, you depend on the atmospheric. They've got lots of things, tables relating to the atmospheric conditions that cause them to adjust their position.
Can you show me one of these charts or something? Could I see one of these charts?
Oh God, I don't know how much Andy. If I charge you for all the work I do for you, I'd be a bloody millionaire if you had that much money.
Yeah, and then can you tell me what year as well? If you can find one of these charts, what year that these charts were given out to people?
Do you do that much work for Ranty? You'd be a millionaire.
I do. I mean, honestly, I got a whole series of do me this, show me that,
full-time job,
this, show me that, work this out. Whereas Ranty could just shove a couple of pictures together.
You're obviously not married, Rumpus.
I mean, Jesus Christ.
Does anyone want to fill the gap whilst he's looking for that?
Christ.
Whilst he's looking for this this citation.
Well, I can't do both. I can't chat to the idiot and do what you do the research.
Yeah, you just find us that research because it was quite the claim.
Okay, so let me just say you want to find the research of what a sniper has to allow for. Okay.
No, I want to see the chart, one of the charts that you say that they have temperature and all this kind of stuff.
Okay, right.
Yeah,
right,
yeah,
okay.
yeah. And I want.
See if I can find it.
Okay.
I don't have a one to hand.
What's interesting to me is while you're looking at Rumpus, let me ask everybody a question who's listening. I think you have big numbers tonight, Randy. I saw Nathan Oakley in chat. Why doesn't he come in and have a reasonable conversation?
No, that wasn't Nathan, Pete.
Oh, fake Nathan.
Yeah, it was Nathan. It was Nathan.
Okay, well, let's take a quick. Well, John, you can answer this as well. So let's take a quick sort of a poll then amongst all the people who are in here. Not that it means anything, but if on Earth, hang on, John. If on Earth everyone at the same instant wants to point in a vertical position, i.e., straight upwards from their relative position, what direction do you think all will be pointing up at? I'll give you my answer straight away. Just intuitively, I say we're all pointing in the same direction, which is, well, vertically upward. I think we're pointing in the same direction, though, John. If you're in Iceland, I'm in Ireland, and I travel with my jet boots directly horizontally, 100 feet above the air to Iceland, with my hand pointing directly upwards. When I reach you, I think we'll be pointing in exactly the same direction.
Of course, because we are on the same line.
But that's my own point of view.
Well, that's Pete. That's assuming it's a flat Earth, right? Isn't it?
No, it's not assuming anything. It's my. After all, I remember we were all ball earthers as well. So I took it as natural that the answer would be that none of us can be pointing in the same direction, which is what you're going to tell me. You all to be
flat
true,
Earth.
right?
Everybody know now we live on a flat Earth because we have overwhelming observations and looking
Come on,
at.
if you live in a ball, that has to be true, because no matter what your position
can't-
is, because
we
matter
can't-
takes up
we
space.
can't live
right?
on a ball
Even if you're right
because
next to me and you point
if you live on a
directly
ball, everybody will
vertically
die.
upward, you're pointing in a
Plum
slightly
Hub is where the truth is,
different,
gentlemen.
Can I show you
different
what
degree
I'm
off
doing?
of vertical.
Can I show this? Can you see my screen?
Not yet.
Let's have a look.
Not yet. Hey, Toady, let me jump in real quick. Good to see you again, Toady.
Yeah, I just came to say goodbye to Ranty because it's his last show, so that's why.
His last show.
Yeah.
He's another week full of shows, man.
Yeah, one more week.
Oh.
One more
He's
week.
not going anywhere. That was it was clickbait. That's all clickbait.
Oh.
No, it's not. No, I've got one more week. It's fine. Right, okay.
I made a special
Stop your
effort.
heavy sighing, you drama queen. Toady, let me just jump in real quick. So
Hold on,
it's
now. I
not
want to see this chart first.
Right, well, I haven't got the manual. Here's the sniper's manual from the United States Army.
I can't.
Be quiet. And it says here, the light does not affect the objective. However, it does affect the way the sniper sees the target. This effect can be compared to the refraction, bending of light through a medium such as a prism or fishbowl. The same effect, although not drastic, as can be observed on a day with high humidity and sunlight from high angles. The only way the sniper
can you slow down a little bit?
Oh, God. The only way the sniper can adjust for this effect is to refer to past firing recorded in the sniper data book. So he's got a sniper.
Hold on.
We know about it.
So
We
it's
know
not
about it.
refraction.
And up here,
It's just
this is
compared
sniper
to it.
training, headquarters, Department of the Army, distribution.
Yeah, you moved away from that quick.
1 mile. That's over 1 mile. What over 230 miles?
Sniper training. There we go.
Yeah. Put it back up. The point. Put the point.
In a book.
Where did you even have it? He wasn't presenting.
He was.
It's not the reality, just in a book. That's it.
Yeah, it's a sniper training consideration.
No, but nobody's taking count of it. Nobody
1 mile consideration. What over?
Hold on.
People that are doing that, they say, we never look in this.
Just denying this is trained. The snipers are trained to deal with refraction using
That's
their
fucking
tables,
bullshit.
and I've just demonstrated this.
Right, show it us. Put it up again. The part that's relevant.
And tell us who calculates it. Is it the sniper, the spotter? Is there a formula? How is it done?
So he's talking about. So in other words, you have to, have a sniper data. I don't know whether that's a personal thing.
Do nothing.
I don't know whether that's a
Somebody's
personal
writing
thing,
something in the
or
book or something.
universal sniper data.
Same, nothing. It's not the reality.
The point is, they do allow for refraction, and basically what they say is these are the temperature conditions.
Yeah,
and
what?
therefore they then write down the book what they've had to adjust in those particular conditions, and so therefore they have their own personal.
No, not therefore. They are telling us they are not taking count.
Imagine they had to fire from 200 miles away at Mount Canaku, Rumpus. Where
Yeah,
would they
so-
fucking aim?
So this was 1994, Rumpus. Can you find me an earlier book on
No, I
this?
can't. I've
No,
that's
yeah,
more than
he
you need.
can't. Yeah.
No, that's more than you need. I've demonstrated that
Of
it's
course.
it's
No.
in the military sniper training manual. They talk about this effect.
I did
That's
ask
all
you.
there is to know.
I did
Yeah, but
ask
there's no
you.
citation here for anybody to look up. Let's say, for instance, I was researching this and I came to this training manual. I would have nowhere else to go but this training manual as an authority. So I can't verify anything. Like,
Let's
hold
quiz
on,
what he presented
Pete,
to
I'm
them.
talking, Pete.
Okay.
So he's look. It says right here in the middle, on a day with high humidity. What does that mean? And sunlight from high angles. Didn't we already discuss this, Rumpus? You denied that the sunlight and angles of the sun had anything to do with how refraction affects an object, and that's been our point this whole time. So, I mean, again, there's nothing here for us to verify anything. This is an authority to itself.
Oh, in fact, here's the sniper's data book. Right. So, in fact, the sniper data book is a collection of cards, data cards. Right. So each sniper. So this is what they record. So they take a notice of the conditions, the atmospheric conditions, and they remember in their own personal.
No. That's absolutely false. Listen, this is listen. This is an example of how they take the data at the time they're shooting. They don't refer back. They don't refer. They don't refer back to 6 months ago when they took notes on something else. They're No, they're shooting to win the moment.
They just said in that text I just showed, they say you refer to your sniper data book when you're
Right, the data book that you're taking right at the moment. Right at the moment.
So what they'll do, if they've got a new target, so for that in Afghanistan, they'll say, when I was back at college and wherever it was, sniper training college, and I had similar temperature conditions and similar pressure conditions, I made this allowance. And then look up their little sniper.
They went to sniper college in the same conditions as Afghanistan.
In the same conditions, and then reuse them.
They went to sniping
school.
They went to They went to sniping school in the same.
Travis, a sniper would be trained under all conditions.
You twat. They match the conditions. They happen to be Afghanistan. If they happen to have similar conditions when they were doing if they have a card for those same conditions, be quiet, twat. And so then they try and match it against the closest match they've got against their own personal experience with their own data card.
Will you go to the part on Coriolis, please?
And just before you do that, give me a few seconds. I'll shut up then. Rumpus, were you presented whatever you presented in relation to sort of longer distance relationships? Now,
I'm going to take this opportunity to do a shout out to Silent Zero, who gives for $5. Rumpus is always lying. Thank you very much for the super chat.
At Mount Canigou in that image earlier on, there would definitely have to be these refraction considerations taken into account, and ultimately he'd have to end up pointing at some distinct point which was at variance from I guess intuition. Whereas this is what I said earlier on: if I was on that mountaintop taking that camera image, I'd point at it, right, as the camera shows me, and the closer I moved, if my jet boot's allowed, I'd point in a straight line, and gradually, slowly but surely, I'd make my way to the target that I set myself.
Straight line.
But it might be a straight line from the original perspective. But as you approach, hang on though.
As you get closer and closer, you'll be changing the angle to pointing to Canigou,
right?
Because you're not following a straight line. Jesus,
but you're bringing it back to mathematics as well. In reality,
you just said at the start of your earlier point that if you just pointed at it and you followed the straight line to the whatever it is, you would end up there. No, you don't. And just by moving closer to it and carrying on pointing at it means you're not necessarily following a straight line.
If I was to follow this, let me just say this: if I was to follow the sniper instructions that you just presented to Ranty, I have no idea what they're about really, and the distortion, minimal as it is, that applies over a mile. A sniper shoots over a mile. As you're going targeting something that's 200 miles away, which we can see clearly in the image. Hang on, Rumpus, let me finish. He would be aiming somewhere to the far left or far right of the mountain, depending on Coriolis. Right?
What? But that only occur if he's got some wind to deal with. But yes, obviously, I mean, if
what he would do.
Hold on.
Over 200 miles.
Why firing left? Oh, you mean for Coriolis? You mean?
No. You talked about a fishbowl effect, right?
No, I didn't.
In the original quotation.
No, they just said in the text in the manual said refraction, like you see in a fishbowl. They're just trying to explain to people what refraction
but it's negligible over a mile.
That sentence was just simply there to explain what refraction was.
Why, like you see in a fishbowl? How do you see in a fishbowl?
Rumpus, did you find anything on Coriolis here?
That's over a mile as well, Travis.
I mean,
over 1 mile.
Okay,
so
is this a
Can I
reliable
question,
source
please?
or not?
Can I answer the question put by Plain Truth? No, there's no Coriolis in here, but this sniping is usually done over, Lisa, be quiet, twat. You seem incapable of speaking. You seem incapable of speaking when you should be speaking, and you love to speak when you shouldn't be speaking. So a Coriolis is not usually used by snipers. Only very specialized snipers that are shooting over a mile or something would have to take this into account. Snipers mostly operate over a few hundred yards when you don't have to count Coriolis. Most of the time you have to count Coriolis is with artillery. Go ahead.
Shit.
So now you're not talking. Now's your turn to talk. Now say something. No, you can't. You've no idea what it is.
He was a sailor at sea, Rumpus. John was. He fired
He doesn't know. He's got no idea.
Rumpus, can you share that link, please?
Okay.
Where are you going to put it, Randy?
No, you don't need 2 reference frames. No, you don't.
I love
Do
it.
you understand that when you are moving relative to a reference frame, so let's suppose we're in a train and our reference frame we decide to be is the train's reference frame, and I decide to move and I decide to walk up and down the train. I don't leave the reference frame of the train. I'm moving relative to that reference frame. I haven't left the reference frame. I don't have to have a second reference frame. The reference frame can be the train, and I am moving in that reference frame relative to that reference frame. I do not need to consider myself in a second reference frame, although I could if I wanted to. It's not required to do that.
Everything you're saying is a fallacy. I can tell you why it's fallacy, because you are on the same ground. You're on one ground that is moving.
The words you just think you.
The train is moving on the ground you are talking about. You have to talk about reference frame. You have to go to the sky.
Frame from the point of view
You
of the
cannot.
observer.
If you understand what Coriolis is,
You don't understand Coriolis. You are fucking.
If you understand what Coriolis is, you should be able to tell me what the formula for Coriolis force is. Please tell me.
There is no formula. It's a fucking. It's a fucking illusion.
So let me get this right. You're saying there's no formula for the Coriolis force. Is that correct? Is there not a formula for Coriolis?
No.
Yeah, you don't know. You're a twat. Shut up. You're not. You are too stupid to talk to me. Be quiet. Go away and stick your head in a fishbowl, and then look at what refraction is. Jesus Christ. A gibbon has got a better understanding of reality than you have. Jesus.
Right, okay, so listen, can we get somebody else in?
John.
Let's. Who was waiting to talk before? Was it you, Aaron?
I forgot how shouty this all was.
Yeah, it's
very shouty.
Yeah, it is. Might have to.
Formula for that in the real.
Take it easy, John, or else the show will end early.
No, it's fine. It's fine. He can't control himself. He just can't control himself. Right. Okay. So, right, Aaron, you wanted to speak, mate. I guess not.
No, Aaron. Okay.
Anybody else? Yeah, go on, Rumpus.
Yeah. By the way, I checked that difference in those two pictures of the sun were 9%. I said 5. It was 9, so I was 4% out. You said 15.
I said 10 to 15.
Okay. Well, your upper limit then was
12.5 would have been the mean. 12.5 would have been the mean, so I'd have been nearer Rumpus.
Mean, yeah. No, we'll go with your top one, I think.
No, you'll go with the mean.
No, I'll go with the top one.
I said 10.
Okay.
Yeah, well, you might as well
maybe
say
50.
100. Yeah, want to go for a bigger one. I committed
What are you
myself
hoping
to.
for?
Yeah,
Concession
you were wrong.
Rumpus Ranty. Come on, Adam.
Yeah.
Listen, right, Rumpus.
So
you
you're
asked
wrong.
John
So I
Bernard
was-
for.
so
You were.
So when I was perfectly correct.
You were almost. You were 80%. You were 80% out. You were 80% out.
I was close enough to make.
You were 80% out, and even at my highest point, I'd have only been. At my highest point, I'd have only been. Yeah, I'd have only been 60%. I didn't say or more.
You did.
No, I didn't.
Okay, well.
So at my highest point, I'd have only been 60% out. You were 80% out. So.
Ooh.
Just face it, you got it wrong.
Ranty there.
Ranty got it spot on. He actually said the figure, or the nearest figure.
I did.
No, he didn't.
Yes, I did. I said it on each side. I said it's about 5 on each side, you numpty.
You said or more.
What's 5 and 5, Rumpus?
Well,
I
think
I'm going to go with the fact that it was 9% instead of 5%.
That's fair enough. That's a by the way, right? That's a reversion. Okay, hang on, please.
You're wrong.
Just before we forget, that's a reversion back to a previous point. Let me just, while the other point is fresh, Rumpus, you sort of tried to embarrass John about he not knowing the formula for Coriolis.
That's what I was going to say, Pete.
Whatever formula, right? Hang on. Whatever formula you're going to mention to all of us now, how can it be tested and clarified as sort of working proper, true, right, in a real sense? And of course, then you're going to extend it to orbital mechanics. But how can it be clarified in a real sense?
To hit
So in
their
other words,
target.
can you give us a particular example? Hang on, Rob.
I'm trying to.
1 second. So let me just clarify. Hang on. Yes, let me clarify. Can you give us a particular earthly example of Coriolis effect where you've applied the mathematics and it's equated with the real
that you asked me to give you? So artillery, built into guns, modern artillery is a correction for Coriolis. In battleships, and from the First World War onwards, they had allowances for Coriolis. So we know that these things work. We know that if you don't allow for Coriolis,
I'm not asking you for historical details.
If you don't allow for Coriolis and you're going along a battleship at some speed and you're firing at something else that's going along at say 20 knots, then you will miss it at a distance of
what
say
have you
10
to take into
miles
account
if you don't allow for Coriolis.
That's because the Earth is spinning under the cannonball, correct?
Correct.
How did they determine how much of the movement in the cannonball from its position of being fired to where it lands is due to the Coriolis effect and not some other variable that's impacting the ground?
Because
like the wind.
The theory, you can say, we know we're on a spinning Earth, obviously. You can say this is what the Coriolis effect will be. You then take some practice shots, allowing for using the theory that you know about the Earth, and you find that gives you the result. So therefore, you've got a match between the evidence of your shooting and your theory, and you say, aha. And as that works every
step
time,
one,
therefore
assume
you
you're on a
say,
globe.
that is accounting for it, and it works, so we'll stick with it. And we know, therefore, that's the effect.
Brandon,
Step
tell
one,
him what you
assume you're on a globe. Step two, arbitrarily assign movement of the round to the spinning of the Earth.
And
Step
it all works.
3.
Yeah, and it all works.
You adapt intuitively.
It's all
right?
mathematical magic. It's equations.
If the Earth
Your
was
number
not
one
spinning,
assumption
if the Earth
is
was
that
not
the Earth's a
spinning,
globe.
and then you went into different
It's a
places, then it
reification
wouldn't
fallacy.
work. No, it's not. It's just you're an idiot.
Yes, it is.
You can show.
Do you
that
know how
your
those tables are
calculations
produced,
give
Strumpus?
you the results. I mean, I know you don't like it, but the experimental observation is
No.
verifying those calculations. And you would know that if you're saying basically it's a lucky guess or something, and if you then went to a different part of the Earth, a different latitude, then those things wouldn't work.
By
But the fact
quoting
that
off knowledge
for
movement of the
different
round
latitudes
due to the
and for different
rotation of the Earth
speeds,
and
all
not
the
some other
time,
variable
it's
that's impacting
verified.
the ground
Its
from
formulas are verified by testing them. How better could it be? And the fact you wish
Do you
to
know how
that
the
means you
How
tables
did
don't
you
know how
are?
to
test
test
Do you know
the
what the
rotation of
process
the Earth,
is?
Rumpus? How was that tested?
Yeah.
Well, you
How
can,
do they
well,
know that
Bob
the movement
Nodell,
isn't
Bob
due to one of the
Nodell's
other
done that for
variables,
us. He
Rumpus?
got himself a laser gyro, and he found out there was a 15-degree rotation. Which
Oh,
of
now you're
course
going to bring
there
up
You
wasn't.
missed the
Bob?
last
That's
show he
bottom of the
did,
barrel
Rumpus,
glober
where
shit
he
right
explained
there,
all that.
Rumpus.
Well, I agree. Whatever he's done recently to
How
try
do you
and discern
calculate the
that
force that
result,
doesn't affect the observer, Rumpus? Come on. How can you calculate a force that doesn't affect? It's a visual thing.
no, it's
How
not
can
a
you
visual
calculate
thing.
that?
Okay, so hold on, one sec. So Essie. So do you want to inform Rumpus what happened with that 15-degree?
Well, Bob was explaining it. I don't remember exactly how he said it, but Gleam was there. He was talking. Maybe Gleam could do it more justice than me. But basically, it wasn't. It was a 15 mile an hour rotation, but it varied on different latitudes on Earth, and it was not the rotation of the Earth. It was the rotation of the stars, basically.
Right.
So you think the stars rotating would cause a gyroscope to change? My God, you're an idiot.
It's a ring laser.
Who said about a
gyroscope?
If you really believe that, I mean, you'd really.
Okay. Listen, moron. First of all, you dumb moron. The Coriolis effect is a visual effect. Clown show. The Coriolis is a visual effect.
Utter moron, and you are too
You're
stupid
such
to
a
talk to me.
stupid idiot.
Bring in the cow.
You don't realize.
It's going to change the behavior of a gyroscope. You
don't realize how
moron.
dumb you are, and you don't realize how
stupid to
people
talk
laugh
to
at
me.
you when you talk.
Too stupid to talk to me.
You're such a moron that you can't talk on the level of a human being. Is the Coriolis a visual effect or not?
It's not a visual effect. No, it's not.
Is it a visual effect?
No, it's
Excuse
not
me?
just a visual effect. It's a physical effect.
Explain us the Coriolis. Go ahead.
Coriolis is the deviation of an object at 90 degrees to its velocity as a result of being inside a non-inertial reference frame.
Absolutely wrong. 100% wrong. I'll explain you the Coriolis like a 7-year-old child. Like a 7-year-old child, I'll explain you the Coriolis, you moron.
What about angular momentum?
I'll explain to you the Coriolis vision.
For the Coriolis effect, please. Do it now.
Pretend that you're not an idiot. Pretend that you don't believe that math explains everything. You
right,
can't.
hold on.
Explain you the Coriolis effect.
Rumpus.
Like I would explain it to a 7-year-old child. Listen, you moron. Listen.
Right, none of you can be heard right now. So I want you to just calm down and start again. Just calm down. Start again. So, no, wait a minute. No. So, Rumpus, tell everybody this 15 degree that you go on about, right? Tell us what you think happened and what you think the current position is.
The current position, what
Hey,
science
Rumpus,
position or Bob's current
Rumpus, on a
position?
side note, sorry to interrupt you. On a side note, I just posted in the chat link how the ring laser gyroscope detects diurnal motion. So you can use that against Rumpus.
Right, that's from the stars, right? Sidereal motion.
No,
it's diurnal motion.
Rumpus is a moron. He just talks.
A diurnal is, you're talking about apparent drift. That's caused by. You do know what diurnal is, don't you?
That is
the
sidereal.
rotation of the Earth.
Once again, it's not. It's the emotion of the sky. So
it's the rotation of the Earth. If it was just, if you're a moron and you're Montreal, you think the rotation.
He said sidereal.
Right, so he's posted.
Let me quiz you on a few things, genius. You're smart, right? You know about motion, right?
You are. I know what.
Okay, now when you let go of a ball, right? When a ball is spinning, right? Genius Rumpus. When you let it go, what vector does it take?
So the ball's spinning all by itself. It's rotating.
No. You have the ball. You're spinning it on a rope.
I'm spinning. I'm rotating.
You're spinning the ball on a rope and you let it go.
Right.
What
so it's
trajectory
right.
does
Okay.
the
So
ball
spinning
take?
around on the end of a rope. You didn't make that at all clear from your introduction, you idiot. So you're spinning around on the end of a string.
If you weren't talking, you moron, you would have heard I said it a few times, you clown.
Okay, so you're spinning around. So you've got a ball on the end of a rope. You're spinning it around your head. Okay, go from there.
And you let it go. What vector, what trajectory does the ball take?
When you release it, it'll carry on in the velocity that it's got at the moment of release.
Which is what?
Well, it'll be a tangential velocity at the point of release.
Tangential, straight ahead, right?
Yeah.
Okay, so now let's take the scenario on a merry-go-round. I'm on one side, you're on the other, the merry-go-round is spinning, and I throw the ball at you. What trajectory does the ball take?
It goes straight, yes.
Exactly, you clown. You just
moron,
explained the Coriolis effect. The ball goes straight, let me finish.
Okay, now you need
to the person on the merry-go-round, it seems that it's curving, you monkey.
You are too stupid. Let me do that. The only thing you're going to understand.
Right, okay, one at a time.
The only thing he's capable of understanding is a video. So I'll show you a little video which might perhaps.
Can I say something?
One monkey / cloud at a time.
Rumpus, you know that Coriolis is an observational thing, right?
It's visual. That's what he doesn't get.
It's a visual thing.
And he comes here and he calls
it's only visual.
The reference frame of the
it's only visual, idiot.
Just as real as anything else.
It's only visual. That's all it is.
No,
it is.
I hope you're going to show some experimental evidence to back this up, Rumpus, because that's what you said you had, experimental evidence.
Hold on, let me show. I think this is the one. Here we go.
But Brandon, the moving aspect is the Earth, right? Rumpus invokes that.
Okay, let me show you.
Oh yeah, this is going to be some nonsense. Don't worry.
Right. Okay. Can you see my screen? Can you see this YouTube video called "Built for Science"? Can you see that?
The artificial gravity lab.
Yeah. Can you see it or not? Yes or no? Right, morons. I'll assume that you can.
Yeah, I can see it.
I'm so sick of you.
Last video, I was
morons and stupid and shit every other word.
Here we go.
They have nothing. What's going on?
So this is like being
Arm.
and try to feel this force that is.
Not really.
Okay, just to be clear, I'm not putting this on. As far as I'm concerned,
Right, we can't hear anything. Stop sharing that.
Keep going.
Stop sharing it. Pause it.
You won't feel the force anymore.
oh, that's weird.
That's weird, right?
That's so weird.
Stop.
So now you are adapted.
Oh
So
my
if I try to do
goodness.
anything else, I haven't adjusted to it. But that specific movement, my body's not
Rumpus.
That's right.
Stop sharing it.
Wow.
Rumpus, you know we've all been on one of these in the fair.
Right, here we go.
Oh my goodness.
Did you not have the opportunity for one of these?
Here's the interesting bit. Right, so this is what it looks like. So this is the ball being thrown. Right. Now there you saw.
Right, Rumpus.
So therefore, from the reference.
Rumpus.
Oh, for fuck's sake! What do you want?
Do you want to mute that fucking thing?
I did. I can't. I did.
No, you didn't, because it was just blaring through here.
Well, I can't. Okay. Well, I don't know how to stop that. I put on mute on the video. I muted
mute
the
the
video.
page.
Whilst it's still coming through to you. I don't understand how to stop that.
Right, there you go. Right, now do it.
Ball at you.
Yeah, I can hear it. It's coming through again.
Straight at you.
Yeah. Well, I'm afraid I've muted it. If you can see, if you're watching my screen, you can muted the damn thing. I don't know how to stop it coming through.
Don't be afraid.
Yeah, it's nothing to do with that. I just can't hear what he's saying when he's playing the video because it just talks over him.
Who are you trying to hear? Me or the video?
You were talking when you were playing the damn video.
Yes.
Yeah, and the video is 3 times louder than you.
Oh, right. Okay. Well, I don't know how to turn the... What you tell me, I'm not familiar with Discord.
Right, well,
how can I turn the video? Anyway, you hope. Well, just watch it then. Just try and look at what's going on. And okay, ignore what I'm. If you can't hear me, then fine. I've turned it down, off. I've turned the volume down. I don't know what more I can do.
Right, go on.
But the key is to watch. So try and ignore the noisy sound if you can. I mean, mute me if you want.
It'd be better if.
Thank God for that.
And see what happens.
So from the point of view from the inertial reference frame, which is basically us being on Earth, that deviation of the ball is in every single way identical to there being a force present, like a gravitational force or an electrical force or a magnetic force.
Negative.
Be quiet.
Negative. You're so
the
stupid,
reference
Rampus.
frame they're in, it looks like the ball.
Looks, that's the key word, looks.
Yes, but in the reference frame, it is changing coordinates as though there is a force acting on it. So for
Only a visual
intents and purposes,
But it's not a force.
there is in that reference frame, there is an
Rumpus, you're just
acceleration of that ball,
You're
and
just
there is a force,
uneducated,
and
too
that's why we
stupid to
call it a
understand it.
It's not a
fictitious
force.
force. But nonetheless, the object is accelerated in that reference frame. So it has all the same effects as though there is a genuine force acting on it. So there you are. That is what Corus does. It causes real changes in the reference frame we're in. The reference frame therein is like being on Earth, and therefore objects suddenly spin off to the side in our reference frame.
Now, can you
What about
provide
conservation of angular momentum,
Coriolis, please?
Yeah. At the moment of
Conservation of
release,
momentum, you dumb.
at the moment of release, that ball lost its angular momentum and immediately gained its tangential velocity.
The point is, from the view of that in non-inertial reference frame, which is the same as we are on Earth, the ball has a force exerted. It's accelerated, so it seems to have a force
When it's in the dude's
acting
hand,
on it, and therefore in our reference frame on Earth, it has a force acting.
Did you say it seems to have a force?
It all
Every
depends.
single way, it's identical to a normal conventional electrical
Rumpus.
force.
It all depends on the viewer.
But it's fictitious.
Yes, and on
In
the
a
reference
normal
frame,
way,
it's dependent on the fact we're in a non-inertial frame, which we
Well,
are
if you
Earth.
put
It's
listen,
equivalent
if
to
you
a
put a camera,
merry-go-round.
listen.
That's all it is.
If you put a camera on that ball is not gonna see any deviation.
That's right.
It's gonna go
that's not-
straight.
But in our reference frame on Earth,
Well,
and the reference frame of the people in that room, the ball was accelerated to the side
Because
of
you're
velocity.
spinning,
Was not accelerated, you moron.
dumbo.
Are you
stupid
fucking
moron.
kidding me?
You couldn't tell the
idiot.
difference, you utter
You
moron. And from the
moron.
perspective of the
You-
non-inertial reference frame,
Oh my
that
god.
looks like
He
as
said
though
that
there's a
the ball
force acting on
accelerated
it.
to the side.
You utter morons.
You're a clown. You're a
Jesus
clown,
Christ.
Krampus.
I mean, I
That's
can't
what
Right,
you are.
okay,
I can assure
Rumpus.
you.
Right, Rumpus. Can you sort of like take a back seat for a couple of minutes whilst I want to listen to what Silent Zero has to critique about that.
Yeah.
Okay, I'll go and get a drink.
No, he needs to. You need to listen to what he's got to say.
Oh, God. Which Silent Zero is this? Oh my God, that idiot. Do I really have
Just
to...
be changing from one point. You're changing from one point to another point. That's why you see the ball go
Yes,
to
a
the
change
right
of
side. It's not a
reference frame,
force.
yes.
Apply to you, moron.
You're an utter idiot.
But it's a visual
You don't
thing. It's not
understand
like
what being a different reference frame is all about, do you? You don't understand the basics of the problem. You don't
You
understand
see
the
the
basics
deviation.
of the Coriolis force. You don't understand the basics of
Rumpus,
any of this.
Are you gonna let me speak?
I just demonstrated that you had no freaking clue what you're talking about. What are you
Rumpus.
You've demonstrated you're a moron.
The-
You've demonstrated you're a
Rumpus.
moron and nothing more.
Rumpus.
Clown, Rumpus,
I wanna speak. Holy crow.
Okay, you far away, man.
Bro, you see the deviation because you changed position. There was no force applied to it.
Yes,
You're
but-
just stupid, Rumpus.
Right, moron. Can you not see that if you're in your reference frame, that ball is
Rumpus,
accelerating?
Rumpus, can I ask you a
Hold on,
question?
just hold on, answer
In
this
the
first
definition,
point.
in the
And I'll-
definition
hold
of
on, hold on, you can speak in a second. I'll stop in a
Hold
second.
on,
You can speak
Rumpus.
then.
It's a real,
Hold on,
it's
I'm
a
in the
real
middle of
simple
answering
question.
silent zero. You
It's
can
a
speak
real,
in a
it's
second.
a real
You
simple
can
question.
take the next turn, Flat Earth Data. Let me just finish my sentence to silent zero. From the reference frame, if you were to take measurements of the coordinates of that ball inside that room, you would see that it is accelerating to the side as you can see it. It's not just
It's not
a visual
accelerating
effect.
to the side.
So therefore,
It's not-
in that reference frame, there is an acceleration, therefore there is a force. Go ahead, Flat Earth Data.
That ball
Okay,
is
so
going straight. There's just the other side
listen,
catching up to the
listen.
ball.
What's causing the force, Rumpus?
The rotation of the non-inertial reference.
Okay, so what actually causes a force, though?
What actually causes a force?
Yes.
Well, you can have the sorts of reference frame effects like we've got here, which are called fictitious or apparent forces. Or
Right.
you can
What are
have
what are
other-
fictitious forces or apparent forces?
They're caused by a change in the by being in a non-inertial reference frame.
So what is a fictitious force? Does it mean it's a non-physical or a physical thing?
It's a physical thing.
How can
Okay,
be physical
if
when
they
it's
measured,
fictitious,
if you
Rumpus?
measure the coordinates of that ball in that as they see it, they would see that the ball is accelerating.
So listen,
from
Rumpus,
that
how do we
reference
how do we
frame,
de-
there
how do we
appears to be a
determine
force, and
how
they
do we
call it a
determine if
fictitious
how do we
force,
determine
even though it causes an acceleration? Go ahead.
how do we determine the
There's
difference
the
between
deviation.
how do we determine the difference between an apparent force and an actual force in this
With
example?
great difficulty.
Wait a minute,
Oh,
I
what's
just
the
figured it out.
deviation you
I just
experience?
created a new force.
In terms of
Visual
physics,
force.
With great
in terms of
difficulty.
physics, it looks and behaves exactly the same.
Did you
You guys
just
are clowns.
did you
great
just get
difficulty,
visual force?
Rumpus,
Visual
with great
force.
with great
Well,
You heard it
difficulty.
here first,
There are
Randy.
lots of. I'm trying to explain to a moron like more.
Yeah, but did you just
There are lots of names for these sorts of forces. It's called apparent, fictitious,
and
inertial,
visual?
and there's another one. But I just used the word
Pseudo.
because these.
Lambert.
What's an
You
inertial
made
force,
history on your
Rumpus?
last week, bro. You
Hang on, Esty. What's an inertial force?
a new force.
An inertial
found a new
is
force,
exactly
visual
what we're
force.
showing here. An inertial force is exactly what we're seeing in action here.
Well,
And
we're
that's
talking this to it. I'm not
and
looking at
it's
the
the same
screen.
as a fictitious force. It's the same as an apparent force. So
What is it?
although it looks and behaves exactly like any other force, its origins are different. It's not.
Give me an
driven
example
by-
of
not
an
a force.
inertial force.
This
It
one
is
here,
a trick
you
of the-
twat. I've just
I'm not
shown
looking
you
at
a
the
picture of
screen.
one in action.
I'm not looking at the screen. Just
Well,
talk
look,
me
I
through
just
it.
gave you a video which showed the Coriolis force in action. That is an
It's not a
example
force.
of an apparent
It's not a force.
Can you
It's
talk
just
me
a
through
visual
an
thing.
inertial force? What is it?
Somebody threw a ball to
It's also an
somebody.
inertial force. There are lots of different names for this force.
Give me a daily example of an inertial force, please.
Well, if you are spinning on a roundabout, there are would be wanted, but and also the Coriolis force, which you do experience to some small degree.
What do you mean?
And then
That's an inertial force. If I'm on the roundabout, I experience an angular transfer of momentum on the basis that I'm traveling on something that's spinning around, right?
But
if I leave that suddenly, and there's a brick wall in front of me, I'm going to smash into it with the momentum given to me on the very nature of the fact that I'm on this spinning object, which is a certain distance from the center of rotation. Where's the inertial force in that example?
Pete, do you accept in the video? You did just see the video I've just. Did you?
I'm not looking at the screen, man. I'm having a
No,
smoke.
not now. But did you see it previously? Did you see the video of people in a room and throwing a ball at one? Did you see that video? You didn't. Oh, for Christ's sake, Bob.
It's okay.
Go away. Watch the video.
Right, guys. With that, been going for 3 hours 20 minutes. I think it's that's long enough for you guys. It's long enough for me anyway, for sure. Right, I'll leave these guys to carry on chatting. I'm sure we'll have an interesting after show. But for now, that'll do. What day are we today? It's Friday, isn't it? So Saturday tomorrow. It's likely that I'll do a show tomorrow. Likely. Not 100% yet, but it's likely that I'll do a show tomorrow. And hopefully you guys will tune in for the last week. Because, as I say, I won't be doing these shows after probably next Friday, I would think. So, make sure to tune in. Don't miss out. Enjoy it whilst you can. Yep, and I'll see you all in the next one, guys. Take care.